Let's look at this set. On 10th June 2022, a total 243 members of Bihar Legislative Assembly voted to elect 6 members of Rajya Sabha to represent the state. Matlab, 6 people were supposed to be sent over to represent Bihar in Rajya Sabha. Total 7 candidates contested the election, out of which 6 won and 1 lost. Out of 7 people that are in the process, 6 will be winners and 1 will be loser. These 7 candidates belong to 4 political parties, namely A, B, C, D. These three candidates, namely A1, A2, A3, belong to Party A. 2 candidates named B1, B2 belong to Party B, and candidates named C1 and D1 belong to Party C and D, respectively. The election took place under a single transferable vote system. While reading this question at this time in my head, I was reminded of the New York, Paris wala set that we have done earlier, or was present in CAT 2004, I think. And I thought maybe उस type का होगा. तो डर तो लगी गया था उसी time पे, because that set is extremely complex. Although I've done it already, I still find it difficult. So I said light लेंगे बाद में. But ठीक है, let's continue our reading. Under this system, all the 243 voters marked their preference for the candidates. Each voter marked his or her first preference and second preference on the ballot paper. No voter marked any preference more than once. Okay, so 243 voters have marked their first preference, 243 voters have marked their second preference. The following table shows the first preference and second preference votes polled to the 7 candidates. First preference, A को इतना मिला, B को A2 को इतना मिला, A3 को इतना मिला, so on and so forth. I am hoping that these totals add up to 243, because we were supposed to have 243 voters. Baki, I'm not confirming that, because if it is not adding up to 243, question would be wrong, and then I can happily move on. Now we are told the weight of the first preference votes was 100, weight of the second preference vote was 50. Effective votes polled by each candidate for different preferences was equal to the number of votes for that preference into weight for that preference. Now, given that the numbers given to us are 150, instead of working with 150, let me work with 1 and 0.5. Because what that would do is, I can happily turn this to 5.5, I can turn this to 8, I can turn this to 40, I can turn this to 13, I can turn this to 55. And then for C1 and D1, I don't really need to see, but I know overall votes that they have received. And this is what I did in the while solving it for the first time as well. Simply 0.5, multiplied it, and I now know the actual score obtained from the second preference votes. The counting of the votes for the election took place in the following rounds. Round 1. A quota to win the election is defined as follows: 100 into the total number of votes divided by the number of seats to be filled plus 1. Given this is round 1, the number of seats to be filled is 6 itself. So this mathematically would be equivalent to 100 into 243 by 7 plus 1. Now this is slightly complicated. So what I did was 210 I know is divisible by this, So this will turn to 24500 by 7 plus 1 minus 200 by 7. This much I can work with. So 24500 by 7. This will give me how much? 3500. So I have 3501 minus, now 200 by 7 will be equivalent to 28.196. 4 by 7.56 or 57. So this will be equivalent to, let me make it 0, let me make it 7. So पहले 28 गया, तो 3472.43. This much we have got. All the candidates who have polled more effective votes through the first preference votes than the quota are declared elected. अब देखिएगा, votes इतने चाहिए इलेक्ट होने के लिए। A1 has got 44, 44 into 100, तो A1 इलेक्ट हो गया। राउंड 1 में ही A1 got elected, A2 got elected, A3 will not get elected because 22 into 100 is less than this. B1 got elected, B2 will not get elected, C1 got elected, D1 is not elected. 4 लोग राउंड 1 में इलेक्ट हो गए। ओके, अब राउंड 2 की बारी आई। The excess votes for the candidates who win in round 1 are calculated as follows. Excess votes is equal to effective votes polled by the candidate to the first preference votes minus the quota required to win the election. मतलब अगर A1 के लिए excess votes निकालने, A1 के लिए excess votes निकालने, it would be 4400 minus 3472.43, तो यहां पे आ जाएगा 927.57. excess votes with A1 would be this much. अच्छा, A2 would be how much? 4100 minus this. अच्छा, 4400 से 4100 गया, 300 कम हुआ, तो ये 627.57 आ गया। अब C1 के लिए एक्सेस वोट्स देखना है। C1 के लिए एक्सेस वोट्स हो जाएगा 4100 अगेन, तो 627.57। अच्छा, B1 के लिए भी देखना है। B1 के लिए अगर देखना है 41 से 36 500 कम हुआ है, तो 127.57। ये सब एक्सेस वोट्स आ गए सबके हमारे पास। नाउ excess votes is this. These excess votes are transferred to the candidate of the same party who has not yet been elected. तो A1 A2 के जो वोट्स होंगे रफली 1554, they will go to A3. So A3 के पास, A3 would have 2200 plus 1554, ऐसा कुछ आ जाएगा A3 के पास। B2 के पास B1 का एक्सेस आ जाएगा तो 2600, सो B2 के पास 2727.57 कुछ बन जाएगा। C1 के पास कोई ट्रांसफर करने के लिए है नहीं, D1 तो इलेक्ट ही नहीं हुआ था, तो कोई लोड ही नहीं है। ओके, The excess votes are transferred to the candidate of the same party who has not yet been elected. If there are multiple such candidates, the excess votes are equally divided among such candidates. This is a non-necessary condition because we don't really have that condition. Therefore, the effective votes of the candidates who have not yet been elected is equal to effective votes polled through the first preference votes and the excess votes transferred from the winning candidates. The 3 people who were not elected were A3, B2 and D1. D1 का तो इफेक्टिव वोट्स 3300 ही है, यहां पर एड करके 3654 हो जाएगा, और यहाँ पे 3300 ही है। The candidates who now have effective votes more than the quota are declared elected. Out of these 3 people, the only person who has more votes than the quota was 3472.43, is A3. So हम लोग राउंड 2 में A3 को इलेक्ट कर जा रहे हैं। अच्छा, लास्ट बिट, the effective votes polled through the second preference votes are added to the effective votes polled by the candidate up to round 2, including the excess votes transferred to round 2. So B2 यहाँ पे है, B1 यहाँ पे है। If n candidates are yet to be elected, the top n candidates among the unelected candidates in terms of effective votes in round 3 are declared elected. इन्हीं दोनों के बीच लड़ाई है, D2 और D1 के बीच में लड़ाई है। इसमें हमसे पूछा है the effective votes polled through the second preference votes are added to the effective votes. D2 के पास सेकंड प्रेफरेंस वोट्स थे 110, तो 5500 वोट्स और आ जाएंगे B2 के पास, एंड D1 के पास तो कुछ था ही नहीं, तो 0। ओवरऑल B2 के पास वोट्स हो जाएंगे समथिंग वेरी लार्ज और इसके पास बहुत छोटू। तो between the two of them, if n candidates are yet to be elected, the top n candidates among the unelected candidates in terms of effective votes in round 3 are declared elected. B2 elect हो जाएगा, तो in round 3 we will have B2 elected now D1 will remain as the candidate that doesn't get elected. Which among the following candidates was not elected? Answer is option 2, D1. Next question, which of the following was closest to the number of effective votes polled by A3 before getting elected? अब यहाँ पे हमने एक एरर कर दिया है. This should have been 3754. 3754 हमारे हिसाब से 3754 के सबसे करीबी वाला ऑप्शन इज 3755. So we will mark that. Next is, which of the following was the closest to the excess votes of A2 at the end of round 1? A2 के पास excess votes थे 627.57. So option B, 628 works. How many candidates were elected in round 2? In round 2 only A3 was elected. So just one candidate, and that is the entirety of this set. This is a boring set. This is a slightly time consuming set. At the same time, it is not very difficult. If you are unable to figure out any other sets in the exam, spend time on this, waste time on this. You will learn something fun. Stopping it now. Ethiopia has 8 aviation centers in 8 different zones. The number of aeroplanes manufactured in a year at each center is 20. Okay, at each center, the number of planes manufactured is 20. The following table shows the number of aeroplanes manufactured in 8 zones in quarter 1 and quarter 2 of the year. It is known that in any particular quarter, no 2 zones manufactured an equal number of aeroplanes. इसका मतलब है, in a quarter, agar no 2 zones manufactured an equal number of aeroplanes, all the numbers in the column are going to be distinct. The number of aeroplanes manufactured by North Zone in quarter 3 is less than the number of aeroplanes manufactured by North Zone in quarter 4. Okay. So if I were to go ahead and write down quarter 3 and quarter 4 here, I know if this is A, this is B, A is less than B. This condition we know. At least one aeroplane was manufactured in each zone in each quarter, and the maximum number of aeroplanes manufactured in any zone in any quarter is 9. अच्छा, अब यहाँ पे एक इंटरेस्टिंग चीज नोटिस करना, there are 8 numbers to be recorded here. And the number of planes that can be manufactured at any place is 1 to 9. मतलब एक कॉलम का समेशन should ideally be 45. हर जगह 45 होना चाहिए था. But we are told for each of these, because the total number of planes created is 20, can I say a total of 160 planes have been created? Out of possible 180, 160 planes have been created. So which numbers are excluded in every quarter? Let's see about that. Quarter 1 may, if you go through the numbers, 2 is excluded. 2 is excluded. Quarter 2 may, if you go through the numbers, 1 is excluded. Once we figure this out, can you see? Out of 180 possible numbers, summation of 180, अगर 160 आ रहा है, is excluded का sum पक्के से 20 होना चाहिए था. 2 और 1 आ चुका है और 2 distinct number होने चाहिए थे यहाँ पे. It is only possible if you have 8 or 9 here or 9 or 8 here for the excluded numbers. It is only possible if you have 8 or 9 here or 9 or 8 here for excluded numbers. If you are able to catch on to this, the subsequent recording becomes fairly straightforward. Let me create everything that I need. Quarter 3, quarter 4, and then excluded. 2 is excluded here, 1 is excluded here. Let me draw lines. Once you have figured out this 2, 1, you get 9, 8 or 8, 9. 17 can only be made this way. You cannot have 10, 7. The only 17 is the highest possible case, which can be made with 9, 8 and 8, 9. Additionally, for quarter 3 and 4, because we have the number of planes made in the first 2 quarters, we can simply write down how many planes are to be made in the next 2 quarters. So you have 4 here, you have 3 here, you have 17 here, you have 6 here, you have 10 here, you have 8 here, you have 12 here, and you have 13 here. We have got these numbers down, and we also know, let's say if this was A and this was B, A is less than B. This we know from earlier. Now, of course, whenever we have cases possible, whenever we are doing that, always look at extremes. If you're supposed to get 3 here, it can only be possible if you have 1 or 2. Correspondingly, it would be 2 or 1 here. Similarly, for Southeast, because 17 planes are to be made in the next 2 quarters, it will either be 8 or 9 or 9 or 8, which means at this time itself, you can happily conclude that none of the other zones are going to have the number 8. None of the other zones are going to have the number 8. And now, when you come back, look at 13. Look at 13. You have to make, see, you cannot, numbers which are no longer in use or no longer available for us to use, we will also keep a track of that. Eight and 9 are not available. In order to make the 13 for West, it is only possible if you have 6 or 7 here and 7 or 6 here. This is done. The smaller number is now 4. Now 4, you can either have 1 3 or 2 2 or 3 1. These are the 3 cases possible. But because Northwest is definitely using at least 1 2 in one of the 2 quarters, you cannot possibly have 2 2 there. So the only possibilities are 3 1 and 1 3. We have also recorded this. Okay. Now see, interestingly, can you see 1 is no longer available? It will either come in northeast or it will come in northwest. It will either come in northeast or come in northwest. So I'm saying for quarter 3 and quarter 4, 1 is not available, 1 is not available, 8 is not available, 9 is not available. None of these cases are possible. Okay. Let's look at southwest now. Let's look at southwest. 6 is supposed to be made. And you cannot have 3 and 3 because one of the 3s is definitely going to be used by northeast. You cannot have 1 and 5 because 1 is not available. So the only way 6 can be made is either 2 4 or 4 2. And now northwest or southwest, one of these two will definitely make 2 in quarter 3 and quarter 4. That is definitely known. So 2s are also not available. 2s are also not available anymore. Let's say we want to, now let's look at north. We need to make 10. We cannot have 1 9, not available. We cannot have 2 8, not available. Can we have 3 7? Possibly. Can we have 4 6? Possibly. So we have 2 cases now. 3 7. Sorry. No. The 2 cases here are slightly different. It is not 3 7. It is 3 or 4 and 7 or 6. It is 3 or 4 or 7 or 6. Now see, for quarter 3, one of these 2 spots is supposed to have 3, used up. One of these 2 spots is supposed to have 4, so used up. But for quarter 4, you can no longer have 6s or 7s. You can no longer have 6s or 7s. Now, when you're trying to make South ka 8, how do we make that 8? How do we make that 8? Can I have I made a mistake here? Wait, 3 4 or 7 6? I can have, I don't know. The only possible way I can make it is 1 is not available, 2 is not available, 3 is not available, 4 is not available. So I can have 5 here. I can have 3 here. Yes. Can I have 6 here, but I don't have 2 here? I cannot. I can have 7 here, but 1 is not available. So the only way this 8 can be made if this is 5 and this is 3. And as soon as this is done, if this is 3, this is guaranteed out. If this is guaranteed out, this is guaranteed out. If this is guaranteed out, this is guaranteed out. This is guaranteed out. 2 is used up, so 2 can't be here. So 4 can't be here. So 4 has to be here. And if 4 is here, 6 has to be here. If 6 is here, 7 has to be here. 7 is here, 6 has to be here. Now in both these columns, just one number is left. Which number is that? Let's see. For the first column, the number left is 7. For the second column, the number left is 5. And we now have precise information for every zone for every quarter. This initial excluded part makes our life that much easier. Let us get to individual questions. The first one, for which of the following combinations of zone number of aeroplanes manufactured in quarter 3 and number of aeroplanes manufactured in quarter 4 is correct? So I think it was East 75. East is 75. Answer is option D. Next, which zone manufactured the least number of aeroplanes in quarter 4? It is Northeast. So option A, Northeast. If the ratio of cost of manufacturing an aeroplane in quarter 1, quarter 2, quarter 3, and quarter 4 was 3, 4, 1, 2, which zone did incur the highest cost of manufacturing the 20 aeroplanes? Okay, pay attention. The highest weights are for the first 2 quarters. If you look at these numbers here, if you look at these, this looks like the zone that should have the highest weight. But then again, in case you are a little more maths bound, Northeast, Northwest, South, and Southwest. So I will go ahead and calculate it for Northeast, Northwest, South, and what was the last one? I forgot. Southwest. So for these 4, we have to calculate the totals. Let me do it with a different colored pen. 3, 4, 1, 2, right? So here it would be 27, 28, 3, and 2. Here it would be 24, 36, 1, and 4. Here it would, the next one, it would be 18, 32, 2, and 8. The last one, this would be 21, 20, 5, and 6. So 5 and 6 is 11. 11 plus 21 is 32. 32 plus 20 is, this is 52 total. 18 plus 32 is 50. 50 plus 10 is, this is 60. 24 plus 36 is 60. 60 plus 5 is 65. 27 plus 28 is 55. 55 plus 5 is 60. So among these, Northwest wins. So answer to the third question should be Northwest. Next question is again along the same lines. If the ratio of cost of manufacturing an aeroplane in quarter 1, quarter 2, quarter 3, and quarter 4 was 3:4:1:2, which zone did incur the lowest cost of manufacturing? East, West, Southeast, and North. So we are supposed to find it out for the rest of the places. Again, if you can see, it should ideally be this because they have the lowest manufacturing happening in the first 2 quarters, which are the heaviest ones. This will be 3, this will be 8, this will be 8 or 9, this will be 18 or 16. So for Southeast, it is 3 plus 8, 11. 11 plus 26, either 37 or 36. For North, it will be 12, 24, 4, and 12. 12, 12, 24, 24, 4. So this is 52. Let us do it for East now. This is 15. This is 12. This is 7. And this is 10. So 12 and 7 is 19. 19 plus 15 is 34. 34 plus 10 is 44. Now this is 9 plus 16, 6, plus 14. So we have got how much? 9 plus 16, 25, 25 plus 20, so 45. So we don't precisely know what is the cost incurred in Southeast, but we know for certain it is the lowest. So the answer to the next question has to be Southeast. Let me just confirm. Yes, Southeast. Next, for how many zones the number of airplanes manufactured in quarter 3 and quarter 4 can be determined uniquely? Apart from Southeast zone, we know it uniquely for every other zone. So out of 8, for 7 we can manufacture it uniquely, or we can identify it uniquely. How many airplanes were manufactured in the East zone in quarter 4? East zone quarter 4, 5. So last answer should be 5, and that is the entirety of this set. Stopping the recording now. Set 4. A, B, C, D, E, F, G, H, I represent distinct digits from 0 to 8, not necessarily in the same order. A, B, C, D, E, F, E, and D, F, G, A, D, E, B are two 7-digit numbers, and H, I, A, I, F, H is the sum of these two 7-digit numbers. And then we have whatever is present here. Now see, fun thing. Anytime you add two similar digited numbers, अगर आप एक single digit number, let's say आप 4 और 5 को add करते हैं, तो आपके पास या तो 9 आएगा या नहीं. Even if you were to take the largest two possible numbers, the max carryover that you can have is 1. 1 के ऊपर आपका max carryover जा नहीं सकता. You cannot have more than 1 carryover. So when you are adding two 6-digit numbers, the max carryover that they can have is 1, which is another way of saying H is uniquely identified as 1, and as soon as you identify H as 1, लिख दो हर जगह 1, चलेगा. Now, given that H is uniquely identified as 1, can E and B have to be two single digit numbers lying in the range 0 to 8 that add up to give me unit digit of 1? Can it be 0 and 1? No, because we were told all the digits were distinct. So the two numbers that are here, have to be two distinct numbers, and they have to add up to an 11. If they have to add up to an 11, the cases that you can potentially see would be 8-3 or 7-4 or 6-5 or 5-6 or 4-7 or 3-8. There are 6 cases in total for us to check for E and B. The good thing is, when you look at the subparts of this question, when you look at the sub questions here, you have 2 theta questions and you have 2 questions in which the options are precise, which basically translates into there is just one acceptable case. And as soon as you hit upon that acceptable case, you can happily move on and answer things. And all you have to do is silently, slowly, with a lot of patience, go through every case and see if you can reach an acceptable outcome. If you can, great. If you cannot, then move on to the next case, because there will be one acceptable case for certain. So in order to solve this, what I've done is I've made all these tables here. I don't know how many cases it would take, but I'm simply going to go through every individual single case and see how it would work out. So I know H is 1. I'm first checking E being 8, B being 3. If 8 plus 3 is 1, 1 carryover will be here. Now E I have identified as 8. 1 carryover I've got. So F has to be 2. As soon as I've identified these numbers, I will write it down 2 here. I will write down 8 here. Are there any more numbers? Yes. F as 2 is also identified here. Okay. Now with 8, if I'm reaching 2 here, I also know carryover 1 has to go here. So with 8, I would have to add up 3. And at this time, I can say this is a problem because D and B are giving me identical values. So this cannot be that case. I have ruled out 8-3 as a possibility. Let's move on to the next case. 1-1. Let it be 7. Let it be 4. So if this is 7, this is 7, this is 1. This will have to be 3 because 1 carried over. This is 3. E is 7, one carryover has come over. So D has to be 5. So let me write down these numbers. D is 4, F is 3. Now for 4 and 3 here, or wait, D one more number I have 5. For 4 and 3 here, either it will add up to 8, one carried over being brought over, or it will add up to 7 only, no carryover being brought. So there are two sub cases that we have to work with. So let me have one sub case here as 8, another sub case here as 7, 4, 3, 5, and 5, and 7, 5, 3, and 3, 7, 1, and 7, 4, 1. Okay. Now if I is 7, then this I has to be 7 here also. I and I have to be same. There is no carryover from here to here. Because there is no carryover from here to here, A would have to be 2. If A is 2, this would have to be 2. And this would be I being 7. Yes. This also works out. Oh, the problem here is entirely E is 7. If I also turns out to be 7, that makes it an unacceptable case. So this is gone. Let I be 8. If I is 8, there is no carryover from here to here, which means A will have to be 3. Now, if A is 3, A and F are turning out to be identical. So this is an unacceptable case. So we have entirely ruled out the case of E and B being B and 4. Let's go on to the next one. H is 1, H is 1, H is 1, E and B being 6 and 5. This is 6, this is 5. This is 6, F would have to be 4. E is 6, F is 4. I have one carryover, I have one carryover. So this will have to be 7. This is 7, F is 4. D is 5, D is 7. Okay, thus far we have reached. Now B plus F, it will either be 9 or be 0. Given that we don't really have a digit for 9, this has to necessarily be 0. So if this is 0, this is 0, this is 0. From 6 and 7, one carryover I had already gotten. So it has to be 2 here. I've got it. So one carryover will go from here. And here, 2 plus 7, one carryover I have from here. 2 plus 7. Yes, everything works out well. I've got 2 here. The digits that I've already used up are 1, 2, 4, 5, 6, and 7. The digits that are left are 3 and 8. So this will either be 3 or be 8. This will either be 8 or be 3. One of these two cases. And I have found one acceptable case, all digits being distinct, everything. At this time, I can happily go back and mark all the answers, because as soon as you hit upon that one unique case, you don't need to solve any further. But for peace of mind, we'll also go ahead and solve the other cases. Let this be 5. Let this be 6. This is of course 1. This is of course 1. This is of course 1. 5, 6, 1. So this will be 5. Now this will also have to be 5 because 1 was carried over. Now E and F are turning out to be identical. This case is unacceptable. Let us look at 4 and 7. If this is 4, this is 7, this is 1, this is 1, this is 1. E is 4 here. So this will have to be 6. 1 carried over. F is 6. E is 4. So D will have to be 7. Now D and B are turning out to be identical. So this is an unacceptable case. The only case left to check is E being 3 and B being 8. 1, 1, and 1. If E is 3, D is 8. 1 carried over, so F has to be 7. If F has to be 7 and E is 3, 1 carried over, So D will also have to be 3. E and D will have to be identical. E and D will have to be identical. So this is also unacceptable. And there are no more cases to check. This is the unique case. So let me just write it down. A 2, 5, 3 or 8. 2, 5, 3 or 8. 8 or 3. 2, 2, 5, 6, 6, 4, 4, 6, 7, 7, 0, 0, 0. F was 4 and D was 7. We have all the numbers, everything uniquely identified. Which letter does the which digit does the letter B represent? B represents 5. So answer to the first question is 5. Which digit does the letter D represent? It represents the digit 7. Which letter represents the value of A plus F? A plus F will be 6 and 6 is represented by E. So option B, E. Last question, which letter represents the value of this and this? Now here, A minus B will be minus 3 because 2 minus 5. H minus D, H was 1, D was 7. So this will be minus 6. E minus F, E was 6, F was 4. So this will be 2. And G plus C, we don't know what C is, we don't know what G is, but 3 plus 8, 11 we know for certain. So we get minus 3, minus 6 cancelled off with 11. We are left with 2. So 2 plus 2, we need 4. 4 is given by the letter F. So answer will be option C, F. This is a question which tests your patience. You have to patiently record down every time you hit upon a bad case and then move on to the next one. And that is it. That will be the end of this recording. Okay, people. A truck started from a warehouse W and traveled to 6 depots, depot A through depot F, and stopped exactly once at each depot in the sequence A, B, C, D, E, F, after which it returned to the warehouse. Okay, so thing to notice that A, B, C, D, E, F is in sequence. It's not like we don't know what comes after what. As the truck traveled across the depots, 6 different cartons were loaded onto the truck at different depots and unloaded from it at different depots. In any depot, the unloading of cartons, if any, is done before the loading of cartons, if any. So unloading happens before the loading happens. Okay. The weight of the 6 cartons were 2, 2, 3, 4, 7, 7. Okay. So total weight is around 25 tons. Further, the truck was empty when it arrived at depot A and was empty when it left depot F. Okay. It is also known that blah 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 things are given. So, in terms of things that need to be recorded, within this set, we need the depot name. At the time of arrival, what all items are present there? What gets unloaded here? What gets loaded here? And then what leaves the depot. So let me make lines for A, for B, for C, for D, for E, and for F. Okay. The order of depots that was listed was A, B, C, D, E, F. When it arrives at A, it had 0. When it left F, it had 0. Nothing left. If it is arriving at A with 0, of course it is unloading 0 here. And if it is leaving F with 0, it must have loaded a 0 here. This much is known. Okay. Next. If at no point were the two cartons of the same weight present in the truck. So 2 ton cartons and 7 ton cartons have to be loaded into the truck and unloaded from the truck at different points. Okay. The total weight of all the cartons in the truck at any given time did not exceed 9 tons. The sum of the cartons in the truck should not exceed 9 tons. Okay. Exactly one carton was unloaded at each depot, except the first and at the last depots. Now see, at the first depot, nothing was unloaded. And even at the last depot, not one was not unloaded. Given that there are 6 cartons, the only way distribution can happen is if one was unloaded here, one was unloaded here, one was unloaded here, one was unloaded here, and 2 was unloaded here. What are those weights? We don't know right now. Okay. The 4-ton carton was unloaded at the third depot after the depot at which it was loaded. Now, this statement means either it was loaded at A and unloaded at D, or it was loaded at B and unloaded at E, or it was loaded at C or and unloaded at F. These are the only 3 combinations. If it was loaded at A, the third depot after A is B, C, D. So it would be unloaded here, loaded at A, unloaded at D, something along those lines. The 4-ton carton will have these 3 possibilities. Next, except for the 2 2-ton cartons, both the 2-ton cartons and the 4-ton carton, every other carton was unloaded at the next depot after the respective depot at which it was loaded. Which is a very funny thing to say. Basically, 3, 7, and 7, these cartons, which weighed 3 tons and 7 tons and 7 tons, wherever they were loaded, in the next stop, they were unloaded. Okay. A total of 5 tons was loaded onto the truck at depot C. Now, see, 5 tons, how can you make this combination? The only way you can do it is 2 and 3. The only way you can do is 2 and 3. So, 2 and 3 was loaded here. From the previous line, I also know 3 was unloaded at the next stop. So I know at D, 3 was unloaded. This is done. Okay. And D and F were the only depots where no cartons were loaded onto the truck. No carton was loaded onto the truck here. No carton was loaded onto the truck here. Okay. Now, next thing is point 4. The 4-carton truck was unloaded at the third depot after the depot in which it was loaded. Can it be A and D now? Can these 2 spots work? No, because it is 3 here. It is not the 4-ton depot. So gone. Can it be C and F now? No, because at C, 2 and 3-ton cartons have been loaded. So it can, this 4 cannot be loaded here and then dropped off here. This is gone, which means the 4-ton carton was necessarily loaded at B and unloaded at E and unloaded at E. Okay. So we already have storyline for where this 4 has gone, where this 3 has gone. About 2, this 2 which got loaded at C has to necessarily therefore be unloaded at F. Has to necessarily be unloaded at F. This is also identified. Okay. Now whatever is the number here, whatever is the number here and whatever is the number here, these 2 numbers would be identical. Or maybe because, okay. Now I know, see, E, the loading, the only numbers that are left. See, 4 is used up, 3 is used up, 2 cannot be here because if 2 was here, the 2 2-ton cartons would simultaneously be present in the truck. That is unacceptable. So it has to be 7 here, and it has to be 7 here. This also I am aware of now. Wonderful. Let us now go to this 1, 2, 3. Okay. So what was loaded here has to be 7 and 2. This 0 is tripping me up. What has to be loaded? There are only two weights left. One 7 and one 2 is left. The 7 which was loaded at depot A has to be unloaded at depot B. And now the only carton which is not unloaded anywhere is the 2 kg, 2 ton one that will go here. We have everything identified. So let me write that down. At the time of arrival, it would be same as what left A, 7 plus 2, 7 unloaded. So what leaves here is 2 plus 4. What comes here is 2 plus 4, unloaded 2. What leaves here is 2 plus 3 plus 4. What comes here is 2 plus 3 plus 4. What leaves here is 2 plus 4. What comes here is 2 plus 4. 4 is gone. What leaves here is 2 plus 7. What comes here is 2 plus 7. What leaves is 2 plus 7. And now I have all the information that I need for this set. Let me get to individual questions. Which of the following cartons was unloaded from the truck at depot B? At depot B, what was unloaded? 7 ton carton. So option A. While leaving which depot did the truck have at least 3 cartons in it? 3 cartons are present when it was leaving depot C. So answer has to be option B, depot C. At which depot was the 4-ton carton loaded onto the truck? The 4-ton carton was loaded onto the truck at depot B. So it has to be option D. Finally, considering only the depots at which at least one carton was loaded onto the truck, what is the minimum total weight in tons of all the cartons loaded onto the truck at any single point, at any single depot? Let's see. Here 9 was loaded, here 4 was loaded, here 5 was loaded, here 7 was loaded. So the lowest number out of these is 4. So the answer to the last question of the set will be 4. That is all that there is to this question. Ravi had a calculator which had 10 digits and all the basic mathematical operators. He decided to clean the calculator by removing all the keys, and while reassembling it, he interchanged the locations of 3 pairs of keys. For example, if he replaced the key 9 in the place of key 6, he placed the key 6 only in the place of key 9 and not any other key. Okay, so let's say A was replaced by B, then B will also be replaced by A. All the 6 keys that were interchanged corresponded only to the numbers and not to any mathematical operators. Okay. Later, he input some calculations and obtained outputs as provided in the table below. The input is shown in terms of keys that Ravi pressed, while the output is the output displayed by the calculator. Okay. Let's see. Then you have these numbers, and then we have your subsequent questions. First thing, I will write down all the storylines. He should have gotten what? If these were the actual numbers, he should have gotten 194. No, let me see. 192. He should have gotten 192. If 912 plus 43 was happening, he should have gotten a 955. If 95 and 84 was happening, should have gotten a 179. And if 178 and 19 was being added, he should have gotten a 197. But what he did get was 195, 942, 128, and 192. Okay. Now looking at these calculations, expectations, and everything. So from the first one, we know, looking at this digit 1, Either 1 has remained 1, either, see, 64 is a 2-digit number. 64 is a 2-digit number. 1 to 8, either 1 has remained 1 or 1 has transformed into 0. These are the only two possibilities that you get from the first case. Either 1 has remained 1 or 1 has transformed into 0. But when you look at the fourth setup, I'm going to call these setups A, B, C, and D. From A, either 1 has remained 1 or 1 has transformed to 0. Either this is a 2-digit number plus a 2-digit number, or this 1 has remained 1. 1 cannot possibly have changed with 2 or with 3 or with 4 or with any higher number, because then the sum would not have been 195. So 1 has either remained 1 or 1 has changed with 0. If 1 had changed with 0, can you see this calculation D, this setup D would have turned to a 2-digit number plus a single digit number, in which case we would never have arrived at 192 as the output. A 2-digit number and a single digit number can never lead me to a 192 as summation. The maximum it can lead me to is 99 plus 9, which is 108. I cannot reach 192, which would mean out of the two initial possibilities, either 1 has retained its form or 1 has swapped with 0. This is impossible. So 1 has retained his form. If 1 has indeed retained his form, as soon as some digit is identified uniquely, go ahead and write it down. We have nothing for C so far, but okay. Here I have 1 blank blank plus 1. Whole thing divided, whole thing adds up to 192. Okay. Now from B, inference drawing. 912, a 3-digit number and a 2-digit number is adding up to give me 942. A 3-digit number and a 2-digit number is adding up to give me 942. So there are again two possibilities. Either 9 stays firm, 9 has not switched, or 9 has switched with 8. These are the only two possibilities that you get from B. Had 9 switched with 7, the sum would not have reached 942, because 700 something plus a 2-digit number cannot lead me to 900 something. So these two possibilities exist. But if these two possibilities exist, look at setup C. If 9 and 8 has switched over, we would have 8 something and 9 something getting added. Can you see the summation here would have been 170 plus? The correct summation would have been 170 plus. But the summation that we are getting is 1 to 8 only. The summation that we are getting is 1 to 8 only, which would mean 9 switching with 8, 9 flipping with 8 is not possible. Because 9 flipping with 8 is not possible, then 9 has held firm, 9 has retained its value. If 9 has retained its value, I am going ahead and writing stuff down all over again at every potential place that I can. Once I have written this down, 128, blah, 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 blah. Now see this for setup D. For setup D, I have 100 something plus 179 gives me 192. Can I get this 100 something? Very easily. This will necessarily be 173. So 7 has remained 7. 7 has also held firm. 1 has held firm. 9 has held firm. And 7 has held firm. These numbers have held firm. But 8 has flipped with 3. This also I know. 8 has flipped with 3. Okay. So if 8 has flipped with 3, then let me go ahead and write everything down wherever I can. 3 would have flipped to 8. 8 has flipped with 3. Okay. Now see, in the first setup itself, 3 plus something leads me to a unit digit of 5. 3 plus something leads me to a unit digit of 5. Can I see it will necessarily be 2? 3 plus 2 will lead me to 5. So I now know 4 has flipped with 2. If 4 has flipped with 2, let me go ahead and edit everything everywhere that I can. This will turn to 4. This first thing would turn to 4. Now the only digit missing is here. 143 plus 52 gives me 195. So I also now know 6 has flipped with 5. The question told me there are only 3 pairs that have flipped with each other. So the fourth digit 0 has maintained its value. And now I know the precise workings that have happened here. I have the precise calculation, precise machinations that are happening, which keys have flipped, which keys have remained constant. I know everything. Let me get to individual questions. The key of which of the following numbers was not interchanged with any of the numbers of the calculator? 2 had indeed flipped with 4. 3 had indeed flipped with 8. 5 had indeed flipped with 6. 7 remained firm. 7 is here. What will be the output if Ravi inputs 814? So 812,270. It adds up to 1082. What will be the output? The output would be 1082. For which of the following numbers will the output of the calculator be same as the input? This would only be possible if the numbers that have held firm, that have not changed their values, or the digits that have not changed their values, those are the ones used. 9 has held firm, but 5 and 8 have flipped, doesn't work. 7 has held firm, but 6 and 4 have flipped values, doesn't work. 4 has flipped values, doesn't work. Option D by default rep, 1, 0, and 7, they had not flipped the values, so they stay. Next is which of the following, if put into the calculator, will have the same output as that when 1, 2, 3, and 4, 5, 6 is put into calculator. 1, 2, 3 would turn to 1, 4, 8, and 4, 5, 6 would turn to 2, 6, 5. If I add these up, I should get 3, 1, and 4. I should get 4, 1, 3. So I'm looking for the pair within the options that gives me 4, 1, 3. For this one, I know the unit digit will be 0 because 9 plus 1 is 0. 9 and 1 had held firm, they had not changed their values. Here, the unit digit would be 4 because 2 has flipped with 4 and 0 had held firm, so it will be 4 only. For option C, 9 held firm, 2 had flipped with 4. So 9 plus 4 unit digit is indeed 3. So possibly the answer. Last one, 8 had flipped with 3. Unit digit is also 3 here. So which means I would have to do the calculation for C and D. So 439 turns to 289. 142 turns to 124. If I add it up, I get 413. So yes, this is the right answer. For peace of mind, we will also look at option D. 158 is 163. 420 is 240. When you add it up, you will get 403, which is not equivalent to what we want. We wanted 413. So option D is wrong. Option B is wrong. Option A is wrong. Answer is option C. Now the second part of this question, which is a different test in itself. Ravi entered A, B, C plus E, D, A into the calculator, where A, B, C, D, E represent 5 distinct digits. Remember this? This distinct is important. The calculator displayed the output to be a 4-digit number ending with units digit of 6. However, he manually calculated the answer and found the correct answer for ABC plus EDA to be a 3-digit number, BEA. Okay. So I'm saying A, B, C, E, D, A ended up with a 4-digit number ending in 6. This is the calculator output. But in his manual working, he got A, B, C, and E, D, A. These two added, he ended up with B, E, A. Can you see unit digit for his manual working is unit digit. C plus A is giving him A. C plus A is giving him A. The only way this works is if C was 0. If C was 0. Now if C is 0, A's actual value, pay attention, A's actual value is 6. I don't think we have written down the flippings that have taken place. No, 2 and 4, 5 and 6. If actual value is 6, key wise, what would be displayed would be 5 and 5. So basically, we have 5 something 0 plus something something 5 is ending up with something something 5. This is what his manual calculation looks like. Okay. Now E, for E, can you see E cannot be, E can only assume values of 1 or 2 or 3 or 4. It cannot take 0. It cannot take 0 because we were told the digits are distinct. If C is already 0, E cannot be 0. If E is 1, it also, now remember, this is our base setup. Now we are checking cases. Now we have to check cases. If we have 5 something 0 and 5, I am taking E as 1 now. So I would have gotten how much? 1 and 5. E and E are common here. I have gotten 1 and 5 already. Now B here would have to be either 6 or 7. 500 plus 100 something. 500 something plus 100 something will give me a result either in 600 or in 700. So let me check with both these cases if anything is possible. If it is 600, if it is 6, if B is 6, would it work? 560 plus 100 something cannot give me 650. So 6 is not possible. Let me check with 7. 570 plus 145 can give me 750. 570 plus 145 can give me 750. It is fulfilling all the conditions of his manual calculation. The extra check that we have to ensure is, okay, these were the numbers. If these were the digits that were in play, A, B, C would have effectively turned into 6, 7, 0 plus 1, 2, 6. If I add these up, I get 7, 9, 6. This is not a 4-digit result as we expected. This is not a 4-digit result as we expected, and therefore this cannot happen. And therefore this cannot happen. This case is rejected. 570 and 145 is rejected because when you translate them into their actual values and then add them up, you don't get a 4-digit result as the question is telling us we should get. So 5 and 1, E possibly having the value of 1, that case is eliminated. Let us look at 5 something 0 and 2 something 5, something ending with 5. Can you see the result here will either be 700 or 800? As in the leading digit here, B, will either be 700 something or 800 something. Let us try with 700. If this is 7, this would be 570. 570 plus 200 something cannot give me 725. So 7 doesn't work. Let me check with 8. 580 something and 825. 580 and 245. 580 and 245 does indeed add up to 825. So the last check that I have to do is, let me translate these numbers into their actual values. I get 630, 4, 2, 6. If I add these up, I get 1056. So yes, this is an acceptable case. Let me erase this 8. Looks a little bad. This is an acceptable case. A is 5, B is 8, A is 5, B is 8, C is 0, E is 2, D is 4, A is 5. Yes, we are getting our absolute result, and the calculator will also return a 4-digit number. So the case with 5 and 2 has been checked now. Let us check the case with 5 and 3. I am erasing portions on the top. I had 5 something 0, and what was it? I'm checking with 3 something 5. The summation here should either add up to 8 or 9. If I went with 8, hopefully you can see the problem. 580 plus 300 something cannot give me 835. 580 plus 300 something cannot give me 835. It will definitely give me something more than 880. So this is bad. So the only way it works is if this was 9, if this was 9, this was 345. Yes, all the conditions are met. Let me check the actual values. 690 and 826. If I add them up, I get 6 1 1516. It is indeed a 4-digit number. So we get another acceptable case here. We get another acceptable case. Now the only case left to check is if E was 4. If E was 4, we would have this. Within this, now because it is a 3-digit number, this has to be 9. If 590 plus 400 something is happening, if 590 plus 400 something is happening, the result has to be greater than 990. The result has to be greater than 990, but the result here is only 945. So this is also impossible. There are only 2 acceptable cases, these 2. Let us look at the individual questions. What is the sum of all possible values of the 3-digit number BEA? It is 825 and 935. 825 and 935. They add up to give us 1760. Answer to the 5th question is 1760. Last, if the value of B is less than the sum of A and D, this is B. Is B less than sum of A and D? No, 5 plus 9 is not less than 5 plus 4. But here, 8 is less than 5 plus 4. 8 is less than 5 plus 4. What is the output displayed by the calculator? The output displayed by the calculator would be 1056, and that is the entirety of this set. Within this set, a good way to proceed would have been attempt the first 4 questions because they are fairly easy to manage. For the second part, in which you have to check cases and get into a lot of in-depth handling, leave that for later. That also works, but it wouldn't be advisable to attempt all of it in one go straight away. That will be all for this set. Let's look at this question. The students of a class like 4 subjects among physics, chemistry, maths, and biology. Each student likes at least one subject among the 4. The bar graph below shows for each subject the number of boys in that class who like that subject, the number of girls in that class who like that subject, and the number of students who like only that subject. Okay. First question is, what is the maximum possible number of students in the class? Can you see there are 90 boys and girls? There are 90 kids who like physics, but among them, there are 10 who like exactly one. There are 10 who like exactly one. And there are remaining 80 are who like one more than one. 80 are who like more than one. When it comes to chemistry, there are 15 who like exactly one, and the remaining 40 plus 45, 15 one. There are 70 who like more than one. When it comes to maths, there are 5 who like exactly one, and there are 50 who like more than one. And finally, when it comes to biology, there are 70 who like exactly one, and there are 40 who like more than one. Now, these kids here, these 100 kids here, they are most definitely a part of our count. They are not a problem. We have these many flags available for people who like physics or chemistry or maths or bio. The question is asking me, I want maximum possible number of students. The students that are left, apart from these 100, the students that are left, they need to carry multiple flags. Yet, you want the maximum possible number of students. The total number of flags available here is 240. The total number of flags available here is 240. You want every student to carry at least two flags. You want to maximize the number of students. Best case would be where every student is indeed carrying exactly two flags. So you would have 120 students who like exactly two subjects, 120 students who like exactly two subjects, 100 students who like exactly one subject. So what is the maximum possible number of students in class? Answer is option C. This is done. Next part of the question. What is the minimum possible number of boys in the class? Okay. If you want the minimum possible number of boys in the class, we would want the overlap. A single boy carrying as many flags as possible. A single boy carrying as many flags as possible. Within physics, how many boys can carry multiple flags? Within physics, how many boys can carry multiple flags? All 50 of them. Let these people who like only that subject be from among girls. Within chemistry, how many boys can carry multiple flags? Let these 15 who carry only one flag be from girls. Within chemistry, that number would come from 40 itself. Within maths, that number would be 30. But within biology, the number of boys who can carry multiple flags. Within biology, the number of boys who can carry multiple flags, it will only be 40. Why? Let all these 50 females be the ones who like only biology, but still we need 20 more, and this deficit of 20 more will be fulfilled from the group of boys. So there have to be at least 20 boys who like only biology. There have to be at least 20 boys who like only biology. So 20 boys, 20 boys, only bio. This is identified. Now, because I want minimum possible number of boys, last time when I wanted maximum possible number of students, my target was let's give each person minimum flags, two flags each only. Here, because I want minimum number of boys, what I would want is let one boy carry as many flags as he can. What is the maximum possible overlap of these four sets? It is 30. Let 30 boys carry four flags each. So you maths is entirely used up. 10 flags of bio are left, 10 flags of chemistry are left, and 20 flags of physics are left. Now let one boy carry three flags each. You can maximum have 10 boys carrying three flags each. Now there will be 10 boys, four flags. When I say four flags, it is physics, chemistry, maths, bio. When I say three flags, it is physics, chemistry, and bio. Now there will be 10 people who carry just one flag of physics, and we have our original 20 boys who carry just one flag for bio. Add it up, 30 plus 10 plus 10 plus 20 adds up to 70. This is the extreme case. Minimum possible number of boys will be 70. The next ones are even more fun. What is the maximum possible number of girls who like exactly three subjects? What is the maximum possible number of girls who like exactly 3 subjects? Okay. Let's see. For the girls, how many girls can like more? How many girls can from among physics? How many girls can like multiple subjects? All 40 of them. All 40 of them. From chemistry, how many of them? All 45 of them. From maths, all 25 of them. From bio, just 40 of them. From bio, why we are not taking the entire group of 50? Hopefully is clear. Because even if I took all boys to be among these 70, we at least need 10 girls to go here. We at least need 10 girls to go here. So this is the count of girls who can like more than one subject. This is the count of girls, or this is the number of flags that can be given to girls who like more than one subject. Add this up, you get 150 flags. What are we looking to maximize? We are looking to maximize girls who like exactly 3 subjects. 150 flags, distribute them out in groups of 3. You can give it to 50 girls. Maximum possible number of girls who like exactly 3 subjects. Answer is option B, 50. Last, what is the maximum possible number of students who like all the 4 subjects? We go back to our initial working. You want from among these 4 numbers, you want maximum possible overlap of all 4 subjects. The answer is the smallest number within this list, which is 40, and that is the entirety of this set. This set is heavily dependent on you being comfortable with the idea of flags and being able to express it in appropriate terms. That will be all. Let's look at this set. 6 friends, Arun, Barun, Charu, Deepak, Ishan and Farah, who share the same flat, purchased some chocolates one evening. They all decided to eat the chocolates together the next morning and stored them in the refrigerator. Anytime you see this sort of setup, know that people are going to betray each other, backstab, and take things out of turn. However, at various times during the night, each of the 6 friends sneaked into the kitchen and ate some chocolates without the knowledge of the others. Backstabbing has happened. The next morning, the 6 friends discovered that only 1/10 of the chocolates they had purchased remained. Okay. So how I'm going about recording it is initial, took, left. First person, second person, third person, fourth person, fifth person, and sixth person. And initially, if there were 100x chocolates, 10x chocolates were left after the last person took it. Okay. None of them ate more than half the number of chocolates that were there in the refrigerator at the time when they went to eat the chocolates. Nobody took more than half. You can take half, but that is like the upper limit. You can never take more than half. Okay. The person who ate last ate only 1/3 the number of chocolates that were remaining when he went to eat. So if he ate 1/3, what is left is 2/3. So he took 5/3, and when he came in, 15x chocolates were left. Or 15x chocolates were left after the 5th person took it. Okay, this is done entirely. Ishan, who was neither the first nor the last person to eat, ate the same number of chocolates as the person who was the last to eat. So I can say Ishan has eaten 5x chocolates. Where that is not the first person, is not the last person. That much I know. But we can see, I can put down not Ishan and not Ishan here. Furthermore, he went to eat before Arun or after Farah. This is a tricky line. He went to eat before Arun or after Farah. He could have gone before Arun and after Farah as well. If it was like this, Farah here, Ishan here, Arun here, this is also acceptable. Or lots of possible cases are there. Lots of possible cases are there. The only unacceptable, there are 5 possible cases of the order of Arun, Farah, and Ishan that emerge from this third statement. But we don't worry about it right now because there are so many cases. We'll worry about it later. Next, when Arun went to eat, only 4/5 the number of chocolates they bought were remaining. So when Arun went to eat, 80x was left. Okay. In the same way, we can potentially write it here. 80x. Arun, who went just before Farah, which means Arun is followed by Farah. Arun, who went just before Farah, ate the same number of chocolates as Farah ate. Farah ate the half the number of remaining chocolates. Okay. See this wonderful thing. He has eaten Y. She has also eaten Y. Both of them have eaten Y. And this was half the number of chocolates that Farah had initially. So Y is left here. Or 2Y was left prior to Farah coming. 2Y chocolates were left, which would be 2Y plus Y is equal to 80x, or this tells me Y is equal to 26.66x. I can replace all these storylines with 26.66x. So 53.33x. Then 53.33x and 26.66x and 26.66x. For Arun and Farha, they come in 2 places like this. Okay. This was done. This was done. Barun ate the chocolates after both Deepak and Farah. And after he finished eating, more than 1/10 the number of chocolates they bought were remaining. Which is another way of saying Barun is not here. Barun is not here. Okay. Now, also, can I say Barun went to eat after Deepak and Farah? So Farha is not at the last spot. Arun is not at the last spot. And Deepak cannot be at the last spot because after Deepak, Barun went. If 5 people have been ruled out, the only person who can come at the 6th spot has to be Charu. Has to be Charu. Okay. Also, this first spot, I know when Arun went in, 80x chocolates are left. So this cannot be Arun. This cannot be Farah. This also cannot be Barun because Barun has to come after Deepak and Farah. This cannot be Barun. And because Charu has been allocated, this cannot be Charu. This has to be Deepak. So Deepak is guaranteed to be here. Charu is guaranteed to be here. Rest of the people I will worry about later. Okay. Each of them went to eat the chocolate only once during the night, and the number of chocolates remaining at any stage was an integer. Okay. This is basic understanding, but we'll work with it. Now, I know Ishan will either come ahead of Arun and Farha, and Barun has to come after Arun and Farha. So there are 3 possible cases: either Ishan, Arun, Farha, Barun, or Arun, Farha, Ishan, Barun, or Arun, Farha, Barun, Ishan. All these 3 cases are possible. All these 3 cases are possible. Okay. So in the original table that I have created, I will work with the first case where I have Ishan here and Arun here and Farah here and Barun here. Let me work with this. I have 100x. Ishan takes 5x. And then he is left with 80x because Arun has 80x when he comes in. He takes 26.66x. And then 53.33x is left. Farah has 53.33x here. Takes 26.66x. And then 26.66x is left here. Then I go, how much? Barun has 26.66x left, but after he takes only 15x is left, which means he took 11.66x. Now for Ishan, 80x was left after he took 5x. So initially 85x was left. So 85x here means what was taken was 15x. So this is the case when Deepak, Ishan, Arun, Farha, Barun, Charu. This was the order in which things were picked up and brought in. This case has been identified. Now I would need to also record the other cases. I would need to record other cases. So what I am doing is, one, I am getting rid of this. I can make one case here maybe. And make a second case here where I have Deepak 100x, and then next is Arun, Farah, Ishan, and Barun, and Charu. The numbers that were guaranteed were 15x, 5x, and 10x. And this was 80x. So you took 20x, and then 80x was left. So 26.66x, 53.33x, 53.33x, 26.66x, 26.66x, and here I will get how much? 26.66x. Ishan only takes 5x, 21.66x, 21.66x here. He has to take 6.66x, so that 15x is left. And this would be the distribution in terms of x when we have the order Deepak, Arun, Farha, Ishan, Barun, Charu. So this case is also recorded. Let me do the third case now. I will have Deepak, Arun, Farha, Barun, Ishan, and Charu. The good thing here is the first three are going to be identical to the red case. So I have 100x, 20x, 80x, then 80x, 26.66x, and 53.33x, then 53.33x, 26.66x, 26.66x. For Barun, we know that initial was 26.66x, but we don't know anything further. But for Charu and Ishan, we know wonderful things. This is 5x, this was 10x. So there was 15x left here. When we come back here, Ishan took 5x, so there must be 20x here, which would mean Barun here has left 20x, which means you took 6.66x. So you got our three possible distributions. Okay, let's get to individual questions. Who is the second last person to eat the chocolates during the night? The second last person can be Barun or Ishan. These are the two people who are possible, Barun or Ishan. So the answer to this question has to be option 3, either 1 or 2. Next, if Barun and Deepak together eat 48 chocolates, then how many chocolates did Ishan eat? If Barun and Deepak, can Barun and Deepak eat 48 chocolates? Here I have 26.66x. Here I have 26.66x. Here I have 26.66x. Regardless of what case I go, I will always have 26.66x, or 80 by 3x is equal to 48. Now Ishan ate 5x chocolates. So cancel 3, 5. So can I say 5x is equal to 9? Ishan has definitely eaten 9 chocolates. Okay. Ishan has definitely eaten 9 chocolates. Next is what could be the minimum number of chocolates that Barun ate. Now this poses a problem. This poses a problem because right now what we have is in terms of 100 or in terms of the large number possible. Let us start doing it, or let us find out the work for what will be the min possible case. The simplest thing that I can see is because I have 26.66, 11.66, 53.33, x has to be a multiple of 3. X has to be a multiple of 3. So if I work that magic, I will get 300, 45, 255, 255, 15, 240, 240 और फिर 1/3 खाया जाएगा ना 80, so 160, so 160, so 80, so 80, so 80, 11 2 by 3, so 15x. This is 45, so this is 35. Then I have 45 and 15 and 30. We can get to these small numbers. Yet, you can see all across them there is 5 common. So I can get rid of 5s also. I can get rid of 5s also, which will get me to 60, 9, 51, 51, 3, 48, 48, 16, 32, 32, 16, 16, 16, 7, 9, 9, 3, and 6. This is the smallest possible case. I cannot possibly bring this down any further. What this also tells me is, the value, the best value that x can take, is equal to 0.6. In the first working, the best value that x can take is 0.6. This tells me that even if I took 0.6 here, my life would be simple. My life would be the same. So I'm going ahead and putting down the numbers here also. Here I would have 60 and 0.6. So 12, so 48, then 48, 16, 32, then 32, 16, and 16, then 16. How much does this give me? 16, 0.6. So 3 and 13. So 13. I need to have 6 here. I need to have 3 here. So 9. So 4. So 9. This is the case for the red working. And I can get rid of all this. I can do the green working also then. 0.6. So 60. And 12. And 48. And 48. And 16. And 32. And 32. And 16. And 16. And 16. 6.66 was 4, no? So 4 and 12. So 12 and 3 and 9 and 9 and 3 and 6. Finally, they've asked me minimum number of chocolates that Barun ate. In this case, Barun has eaten 4. In this case, Barun has eaten 4. In this case, Barun has eaten 7. Minimum number of chocolates that Barun ate will be 4. I've gone ahead and created the entire table. Although for this question alone, I could have simply used x equal to 0.6 and then getting to value of Barun. Next, which of the following pairs did not eat a total of 19 chocolates? Okay, let's see. Arun and Sharu can eat a total of 19 chocolates. Arun and Ishan can eat a total of 19 chocolates. Farah and Ishan can eat a total of 19 chocolates. But Farah and Barun, can you see Farah and Barun, 16 and 4? They can never eat a total of 19 chocolates. They will eat either 20 or some multiple of 20. So The answer to the question is option 4. Next storyline. If after the 4th person ate the chocolates in the night, 39 chocolates are remaining. What is the difference between the number of chocolates eaten by the 4th and the 5th person? When the 4th person has eaten, 16 chocolates are remaining. 16 is not a factor of 39. After the 4th person has eaten, 12 chocolates are remaining, not a factor of 39. After the 4th person has eaten chocolates, 13 are remaining, which is indeed a multiple, a factor of 39. So what is the difference between the number of chocolates eaten by 4th and 5th person? In the simplest terms, the difference is 1. Given that 30 needs to be multiplied by 3 in order to make 39, the difference will turn out to be 3. And that is the entirety of this set. Let's look at this set. A lock has 6-letter combination code where all the letters are distinct. A software was used to randomly try different combinations of 6 letters out of 26 letters of the English alphabet to break the code. The software was able to determine the number of letters that were correct but entered the wrong position, and the number of letters that were correct and also entered in the correct position. The details after 6 trials are shown in the table below, and this is the table that we have. Now within this table, the best trial for us is trial 6. Best trial for us is trial 6 because that has the maximum number of letters in the correct position. Trial 6 has maximum number of letters in the correct position. So what I will do is, one after the other, I will make cases of two letters present in this trial, and then see if they can be the 2 correct letters in the correct position. Checking the case of TA. Would TA work? If TA was correct, if TA were both in correct position, look at trial 2. I also have an A, I also have a T. I should have gotten at least 2 in the correct and incorrect position together. At least 2 I should have gotten. That is not possible, which means TA cannot be the 2 letters in the correct position. Then let me check TS. For TS, look at trial 5. I have a T, I have an S. There should be at least 2 letters in the correct or incorrect position combined. Not possible. Let me check TD. Similarly, trial 5, T and D both are present, just 1 in the wrong position. So not possible. How about T and Q? Again, trial 5, T and Q. At least 2 letters in the correct and incorrect position should be there. Not possible. T and B. Again, trial 5, T and B both are there. T and B both are there. At least 2 of them should be in the correct or incorrect position. The fact that there is just 1 means TB as a pair wouldn't work. Okay, which means T, all possible pairings of 2 letters which is in the correct position, T is not a part of that. Next, let's check AS. How about AS? A and S are present here. Now, in trial 6, A and S, if these were the 2 letters in the correct position, look at trial 2. A is present, S is present, but only 1 letter is in the correct position. So, A and S can't be that pair. How about A and D? Again, trial 2, AD can't be that pair. AQ, again, trial 2, can't be that pair. And AB, let's see, AB can be that correct pair because B 1 correct, A 1, 2 correct, so more than 1 possible. And D, U, C, R, Q, S, none of them are present. A in the second spot itself, potentially correct. A and B, both the letters present, and more than 3 are included in the password. This does not mean AB is definitely the pair that are the 2 letters correct, but AB is definitely a pair for which it is possible for it to have 2 letters correct right now. For us to be certain AB, we would have to rule out all other pairs as well. Let us go ahead and try and see if that works out. SD. SD. 2, if these 2 were in the right position in trial 5, S and D both are there. It cannot be that only 1 is in the wrong position. SD as a pair wouldn't work. How about SQ? Again, with trial 5, I know SQ cannot be that pair. How about SB? Again, from trial 5, I know if SB were the 2 letters in the correct position, S is present, B is present. These 2 cannot be giving me only 1 in the wrong position. So SB wouldn't work. Now, DQ. trial 5 invalidates it. DB, trial 5 invalidates it. And finally, QB, trial 5 invalidates it. So, of all the 15 pairs, see 5, 4, 3, 2, 1, all the 15 pairs of two letters that could have been identified, from trial 6 of two letters that are in the correct position. The only one that is possible is A and B, which means A is in the right position, B is in the right position. And it also means T is not a part of the password, S is not a part of the password, D is not a part of the password, Q is not a part of the password. These four are definitely not a part of the password. With that knowledge, with the knowledge for trial 6, let's go ahead and see about the other trials. I know D is not a part of the password, T is not a part of the password, S is not a part of the password, Q is not a part of the password, and I know B is in the incorrect position, but it is definitely a part of the password. And for trial 5, I know 0 were in the correct position, 1 was in the wrong position, B is in the wrong position is already known. So C is definitely not a part of the password. Let's work forward. S is not a part of the password. T is not a part of the password. Q is not a part of the password. D is not a part of the password. I know A comes in the second spot. Here it is in the third spot. So it is in the incorrect position. And for trial 4, because I need two letters in the incorrect position, E is also in the incorrect position. E is definitely a part of the password. This is also known. Wonderful. Let's work further. D is not a part of the password. C is not a part of the password. Q is not a part of the password. S is not a part of the password. Now, between U and R, one of them is in the right position. U cannot be in the right position because we know A is in position 2. So U is not a part of the password. R is a part of the password. This is known. Let's work our magic further. U is definitely not here. D is not here. Q is not here. S is not here. T is not here. A is here. So trial 2 does not give me any additional info. Let's look at trial 1. A is in the wrong position. B is in the wrong position. C is not a part of the password. D is not a part of the password. S is not a part of the password. So F is definitely a part of the password. So at this time, I'm erasing these possibilities that I've written. At this time, you can be absolutely certain. The password is something blank, something R, F, B, and in one of these two blanks, E is included. One of these two blanks E is included. Now, because we have identified the password or the final code that is needed, what all letters have been excluded, what all letters are still left to be included. We can also do that. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. These are the 26 letters of the English alphabet. We know A is definitely included, B is definitely included, C is out, D is out, E is definitely included, F is definitely included. G, we have no information about G, about H, about I, about J. We have no information about this. G, H, I, J, K. We have no information. L, we have no information. M, we have no information. N, we have no information. O, we have no information. P, we have no information. But Q is out. R is out. S is out. T is out. U is out. Okay. So these many letters remain. For ease of viewing, I am also going to write them down as D, H, I, J, K, L, M, N, O, P, and V, W, X, Y, Z. These are the 15 letters that can still be part of the password. One of these would be a part of the password because the 5 letters that are included we know, and out of those 5 letters, four of them we also know the position. Now, based on this, you have to get to the individual questions. The first question requires a lot of processing, so we will do that at the end. First, let me get through the other subparts. How many vowels are there in the code? Can you see? A is definitely a part of the code. E is definitely a part of the code. Now, I and O can also potentially come in. So, we know for certain, no vowel wrong, one vowel wrong, At most 2? No. You can have 3 vowels also. If I or O came in, that is also possible. At least 2. A and E are definitely a part of the password. So the answer to this question has to be at least 2. Next one, which of the following is definitely true? If all the vowels are together, the consonants would also be together. Let's see. If I had a code like this, GAERFB, can you see the vowels are together, yet all the consonants are not necessarily together? So this is not true. Next is, if all the consonants are together, the vowels would also be together. See, the consonants, 3 of them, RFB, are already here. Either I have 4 consonants or 3 consonants. If I have 4 consonants, then these 4 would be consonants, these 2 would be vowels. If I have 3 consonants, then these 3 are consonants and these 3 are vowels. Regardless of which case I take, can you see the vowels will always be together as long as all the consonants are together? So this statement is indeed definitely true. Answer to the third question will be option 2. Next, if there are 3 vowels in the code, then how many different codes could have been possible? If there are 3 vowels, we know 2 vowels already. Among the left letters, there are these 2 left. So which of these 2 is a part of the code? I can select that in 2 ways. And then whichever letter is selected, that and E can rearrange themselves in 2 factorial ways. So 2 into 2 factorial, 4 codes would have been possible, or option 3. Last, in the true code, what is the position of B? We know position of B is position 6. So 6. We have done 2, 3, 4, 5 of this set already. Now question 1. Question 1. This requires a lot more processing, and in fact, you would do well in the exam to skip over this question and do the other 4 subparts. But in case you have to solve it, it requires this much work that I have to bring it over to another page. The basic informations that we know are, the code right now is dash blank A and R, F, B, and E is definitely a part of the code. And the letters that are still available are G, H, I, J, K, L, M, N, O, P, and V, W, X, Y, Z. These are the 15 letters that can potentially come. Now, maximum number of attempts Raju would have to make before he cracks the code. One, the wording is not appropriate. Ideally, it should say what is the maximum number of attempts Raju would have to make if he's solving it rationally, if he's solving it in the best manner possible. Otherwise, he can happily go ahead and place everything in the wrong position. From here, you can get 30 cases. One of these 15 can be selected, and then along with E, it can be done in 2 ways. So there are 30 total combinations, which would include 1 correct combination. So in case he is doing it stupidly, he will take 29 attempts. After 29 attempts, he does not pay attention. The question does not ask him to input the right code. The question simply asks him to identify the right code. So if he's got 29 wrong attempts, then in the 30th attempt, he would know for certain, okay, this is the right code. So he wouldn't need to go to the 30th attempt at all. But then what this question expects you to do, despite its wording, what this question expects you to do is take the most efficient path to identifying the code and then see how many steps are needed. They take the most efficient path to identifying the code and then see how many steps are needed. Right now, the points of contention for us are whether E is included, where E is included and which of these letters is included. So what I will do is, the first trial, in my first trial 1, I will input the code G, H, E, I, J, and K. G, H, E, I, J, K. What this can give me as output, there are 3 possible outputs that I can get from these. I'm trying to be as expansive as possible so that the explanation makes sense. Either it can give me 2, 0. What I mean by 2, 0 is 2 in the correct position, 0 in the incorrect position. 2 letters are in the correct position of the password, which would mean G and E are in the right positions, which means at this position, I am certain my code is GAERFP. This is right after trial 1, I know. This is right after trial 1, I know. Okay. Next would be, it can also give me 0, 2. Sorry, not 0. Yes, it can give me 0, 2, or it can give me 0, 1. It cannot give me 0, 0. It cannot give me 1, 1. It cannot give me 1, 1. See why it cannot give me 1, 1? It would mean E is in the right position. 2. 1. It can give me 1, 1. In fact, that is a better case to take. It can give me 1, 1. It can give me 0, 2. And then it can give me 0, 1. It can give me 1, 1, 0, 2, or 0, 1. Okay. Now, if this is the case, 1, 1, this is the case 1, 1, can you see? If it is 1, 1, can E be in the wrong position anymore? Can E be in the wrong position anymore? If E was in the wrong position, then G would have to be in the right position. For position 2, for position 4, for position 5, and position 6, you already know the letter symbol. E cannot be in the wrong position, because if E was in the wrong position, then if E was in the wrong position, it is being counted here. Then one correct position would go to G, and if G is necessarily coming here, E has to come here. So E cannot be in the wrong position here. Thus, this tells us, what you can infer from this is, our code is A, E, R, F, B, and there is one letter left. And out of these, what all cases are possible? What all letters can potentially come here? It can either be HI, J, or K. G cannot be that letter which is in wrong position. G cannot be that letter which is in wrong position, because if G is in the wrong position, there is no other spot left for G to come. Okay, right now I'm only doing work for this. So from here, the next check that I would engage in, is this: H, L, I. Remember, this is trial 2. H, L, I, M, N, O. From this, I can get 3 outcomes. Either I will get 1, 0, which would mean H is the right code. H is a part of the code. So my code becomes H, A, E, R, F, B. Whenever I reach the final code, I'll write it with a rectangle. Or I can get an outcome 0, 1, which would mean I is a part of the code. Remember, out of these 4, one of them is a part of the code. So I is a part of the code, and it is coming in the leading place. So I will have I, A, E, R, F, B. Or I can get 0, 0, which tells me H and I are definitely not a part of the code. What is indeed a part of the course? Is J or K. So at this time, I will go ahead and put down J, L, K, M, N, and O. Now from this, I can only get 2 outcomes. Either 1, 0 or 0, 1. I cannot get 0, 0, because see, the original stem where it came from. It came from 1, 1, which means E is in the right position, and out of H, I, J, K, one of them is a part of the code but in the wrong position. Then I check H, I checked here, it did not work. H, I gave me a return of 0, 0. So the next case I'm checking is J and K. One of them is definitely a part of the code. If I get 1, 0, then I know for certain my code is J, A, E, R, FB. Remember, this is trial 3. This is trial 3. This is trial 3. Or if I get 0, 1, I know my code is KAE RFB. So for 1, 1 storyline, the worst I need to go to is up till trial 3. Maximum I need to go till is trial 3, and then I will know definitely what is the code. Okay. Let me also make space. Yes, 1 minute. Let me also make more space here. Other cases, we ended it till here. One case was 0, 2, us getting 0, 2 from trial 1. If we got 0, 2 from trial 1, it means E is in the wrong position. E is in the wrong position. If E is in the wrong position, it means my code now has to be EA blank RFB. This is what I can infer. My code is EA blank RFB, and the remaining spots have to be filled up by either G or H or I or J or K. G or H or I or J or K. Now see, based off on this, the next working that I will do is the next trial 2 that I will put down. The trial 2 that I will put down is very similar to what I did earlier. I will put down HLIMNO. Again, I can have 3 outcomes here. Either 1 is 0, which would mean my code is EAI RFP, because the only unknown spot is the third spot. If 1, 0 I'm getting, it means I is in the third spot. If I'm getting 0, 1, it would mean my code is EAH RFB. Because from this 5, the only 2 I've included are H and I. Or I can get 0, 0, which would mean H and I are definitely not a part of my password. So the next thing I do is I put down trial 3. And here in trial 3, what I will put down is the same set of letters: J, L, K, M, N, and O. But this time, from this trial 3, there are 3 possibilities. Previously, there were only 2 possibilities. Now there are 3 possibilities, because either I can get 1, 0, or I can get 0, 1, or I can get 0, 0, or I can get 0, 0. If I get 1, 0, it means K is in the right position. So my code has to be EAK RFB. If I get 0, 1, it means J is in the wrong position. So J should come in the third spot. So EAJ RFB. If I get 0, 0, pay attention. I got 0, 2 here, which means out of G, H, I, J, K, one of them is a part of the password. In trial 2, I reached 0, 0 while checking H and I, which means H and I are not a part of the password. Then in trial 3, I again reached 0, 0, which means J and K are not a part of the password. So if this is not a part of the password, if H and I is not a part of the password, J and K are not a part of the password, can I say for certain a return of 0, 0 here guarantees that my password is EAG RFB. I am getting EAG RFB. Again, at trial 3, I am able to arrive at this conclusion. Okay. Let me work my magic even more. I would need to write this down.
Trial 1 was GHEIJNK. The last outcome that we haven't checked so far, is when we end up getting 0, 0. Sorry, not 0, 0, 0, 1, because E is definitely a part of the password. If I get 0, 1, then I know my password is definitely EA blank RFB. And at this time, I can also rule out GHIJK. This line is not included in my password. So I am back to my initial position. Think of it this way. I am back to my initial position. So now I would do that check with either LMNOP. My next trial 2 will be LMNOP. And let's say Q. Let me put down Q. From this, can you see, I can get 3 outcomes. The 3 outcomes would be either I get 1, 0 or 0, 1 or 0, 0. 1, 0 would mean N is a part of my password. Remember, the password is set to be EA blank RFB. N is a part of my password, so I get EAN RFB from here. If I get 0, 1, this will require a lot more processing. If I get 0, 1, it means N is definitely not a part of my password. The potential, my password is EA blank RFB, and the potential letters that can come in the next blank are G, sorry, not G. See, this situation is very similar to this one here. Whatever we had here, 5 potential letters and 1 blank. It is the same situation that is happening here. The other letters can be L or M or N, not N again, N or O or O, not even similar to that, no. We have ruled out Q also. So L or M or O or P. These are the only 4 letters left. If these are the only 4 letters left, remember, this is trial 2. This is everything that we've got after trial 2. How many more trials do we need in order to identify what goes there? How many more trials do we need? Previously, we had reached this result after trial 1. And then we needed 2 more trials. So can I say, this result we have reached after trial 2. I will need 2 more trials. We'll need 2 more trials in order to arrive at my final destination. How that would happen is, in trial 3, I'll put down L, M, Q, or Q, L, M, sorry, L, G, M, I, J, K. This will give me 3 possibilities. The 3 possibilities being 1, 0 or 0, 1 or 0, 0. At 1, 0, it would mean M is coming in the 3rd place. So my password would be EAN RFB. At 0, 1, my password would be EAL RFB. At 0, 0, don't need to move this even further. At 0, 0, it would mean L and M are not a part of my password. L and M are definitely not a part of the password. So the additional check that needs to happen is for OP. So I will have trial 4. With trial 4, what will I get? With trial 4, I will get this. What? Trial 4 would be O, G, P, I, J, K. O, G, P, I, J, K. I will either get 1, 0 or 0, 1. Remember, O or P, one of them is actually in the right position. So if I get 1, 0, my password will be EAP EAP, P is in the right position, and RFB. If I get 0, 1, my password will be EAO RFB. Or even still, by trial 4, I know definitely what the password will be. Now the last sub part, if I got 0, 0, after my trial 2, if I got 0, 0, we'll have to move the page around a little bit. Yeah. If after my trial 2, I got, 1 minute, I got 0, 0. Do you see? This means that LMNOP are not a part of the password, which means my password, after trial 2, I know my password definitely is consisting of one letter out of V and W and X and Y and Z. One of these 5 letters is a part of my password at the third spot. One of these 5 letters is a part of my password at the third spot. So I'm again shifting this a little bit. Let's see if we can work our magic from here. Let's up until trial 2 we know. So trial 3, what I'm doing is trial 3, I will put down V G W, and then what else? VGW, IJK. This can give me 3 outcomes, either 1, 0 or 0, 1 or 0, 0. If it gives me 1, 0, remember, this is stemming from here. If I get 1, 0, it means W is in the right position. So the password will be EAW RFB. If I get 0, 1, V is the right part of the password. So I'll have EAV RFB. If I reach 0, 0, it means V and W are not a part of the password. So from here, I will have trial 4, and the trial 4 would be X, G, Y, I, J, and K. From this, I will again get 3 outcomes. The 3 outcomes mean either 1, 0 or 0, 1 or 0, 0. 1, 0 would mean the password is EAY IJK. 0, 1 would mean the password is EAX. Sorry, EAY RFB, not IJK. What have I done? RFB. If 0, 1 means X is a part of the password, so EAX RFB. And if 0, 0, it means X and Y are not a part of the password, which means Z is a part of the password. And the only spot Z can come is, remember, the third spot. So the password here will be EAZRFB. This is a very, very long question. This is a very, very long question that requires this much writing. See, one separate page was also not enough. I had to move around the page to get to the cases. My trial 1 was GHE, IJK, and then in this case, I ended up at trial 1. At trial 1 itself, he knew what the code was. Here, in trial 2, he knew what the code was. Here in trial 2, he knew what the code was. Here in trial 3, he knew what the code was. Here in trial 3, he knew what the code was. Then the other situations. Here in trial 2, he knew what the code was. Trial 2, he knew. Trial 3, he knew. Trial 3, he knew. Trial 3, he knew. Move even rightwards. Move even rightwards. Here he knows after trial 2. Here he knows after trial 3. Here he knows after trial 3. Here he knows after trial 4. Here he knows after trial 4. Here he knows after trial 3. Here he knows after trial 3. Here he knows after trial 4. Here he knows after trial 4. And here he knows after trial 4. Which means the answer to the question, which says, after the 6th trial of the software, Raju tries to break the code with the help of data in the table. He manually enters the code, and each time the software gives the output of number of correct letters in the correct and incorrect position. What is the maximum number of attempts Raju would have to make? The software has made 6 attempts. Raju, how many more attempts does he have to make before he can crack the code? He would have to make 4 additional attempts. Our answer to this first question here is 4. And hopefully now you understand the advice of why leaving alone the first question in this set perhaps would have been the smarter thing to do. That will be all. Let's look at this set. Company P and Company Q are two rival companies operating in the same market segment. Enterprises में companies बोल दिया, कोई बात नहीं. Company P can adopt any one of A, B, C strategy, and Company Q can in turn adopt any one of X, Y, Z strategy. The following table gives the payoff to Company P depending on which strategy it adopts and which strategy Company Q adopts in response. So payoff to Company P is mentioned in the table here. Okay. A positive sign indicates that Company P gains and Company Q loses, whereas a negative sign indicates Company P loses and Company Q gains. Okay. Then these tables are there. For example, if Company P adopts strategy A and Company Q adopts strategy X, Company P loses 800 while Company Q gains 8,000. 8,000 and 8,000. Further, both Company P and Company Q incur a cost in adopting any of the strategies, and the costs are given below in the following table. So, right off the bat, I came up with, let me make combos AX, AY, AZ, BX, BY, BZ, and CX, CY, CZ. What happens to either of the companies when any of these combinations are picked up? For Company P, for Company Q, what happens? If P picks up A and Z picks up X, then it loses 8,000 and it also has to incur a cost of 1,000. So P gets minus 9,000 in total. For Z, it wins 8,000, but it loses 2,800 due to cost. So it has 5,200. Now AY plus 10,000, but 1,000 rupees expenses. So it will only get 9,000 rupees in return. But for Q, 10,000 is lost and 400 extra is lost. So minus 10,400. Now AZ, 12,000 is lost, 1,000 extra is lost. So minus 13,000. 12,000 is gained, but 5,600 is spent extra. So 6,400 again only for Q. Then BX, 11,600 gained, 6,000 spent. So 5,600 spent or gained, 11,600 lost, 2,800 lost, 16,18 is minus 14,400. For BY, 10,400 हारा, 6,000 हारा, तो माइनस 16,400 हारा, 10,400 जीता, बट 400 खर्चा हुआ, तो 10,000 जीता. BZ, 11,001, but 6,000 spent, so 5,001. 11,000 lost, 5,600 lost, so minus 16,600. Now CX, 12,400 lost, 3,000 lost, so minus 15,400. 9,000 gained, sorry,
9,000 gain, 3,000 loss. So 6,000 and 13,000 loss, 3,000 loss. So minus 16,000. इसका देखते हैं CX 12,400 खाया, 12,400 जीता, 2,800 खाया तो 9,600 जीता, 9,000 हारा, 400 हारा तो माइनस 9,400, 13,000 जीता, 5,600 हारा, 13 और 56 तो 7,400 लकीर है. Okay. This will be the payouts for company P and company Q depending on what combination of strategies are picked. Okay, let's see. Which strategy should company P adopt such that whatever is company Q's response, it will always make a net profit even after deducting the cost incurred. For A, is it always getting profit? No. For B, is it always getting profit? No. For C, is it always getting profit? No. And therefore, the answer to the question is option 4. Such a situation is not possible. For whatever decision P makes, there is always a possibility where Q ends up getting a profit and P ends up making a loss. Okay. If P has a very good cash flow and is aggressive and its sole objective is to maximize the losses or at least minimize the gains of company Q, which strategy should company P adopt? Okay. If company A adopts A, the outcomes for Q would be these three. The outcomes for Q would be these three. And here there is a concept called expected outcome. Expected value, expected outcome, expected value from P and C. So in my head, the first idea was, let us see what is the outcome in every location. Here, what is the outcome that I get? 5,200 plus 6,400 gives me 11,600 minus 10,400 gives me 1,200. So expected outcome here is 400. Okay. Here, 16,600, 14,400, I get minus 21,000. So expected outcome here is minus 7,000. And here, 7,600 by 3, the expected outcome is 2533.33. These are the expected outcomes of Q depending on what P selects, whether he selects A, whether he selects B, or whether he selects. And in my wisdom, I said B is the best case possible because him stopping his profit, him maximizing the losses of Q is best case possible here. But then the official solution goes on to say something along these lines. Sole objective is to maximize losses or at least minimize the gains of company Q. So what it says is guaranteeing that loss earned by Q exists, or Q is definitely making a loss. Because that cannot be guaranteed, he will want to minimize the profits of Q. And here he makes a profit of 10,000. Here he makes a profit of 9,600. Here he will only make a profit of 6,400. Best possible outcomes. And therefore, company P will select strategy A. In my understanding, it should be B minus 7,000 based on expected value understanding. But because it says A, official answer is A. What is the maximum loss in rupees that company Q can incur? Company Q can incur a maximum loss of 16,600. So option 2. Next, what is the profit ratio for company T when it adopts strategy A and C respectively? When it adopts strategy A and C respectively. Now see, when it says profit ratio for company P when it adopts strategy A and C respectively, again, I don't know if it will be profit because it is dependent on Q necessarily making the adjustment.
So the solution goes into saying profit will only be made if AY as a combo is picked up and CY as a combo is picked up. Their ratio is 3:2. 9,000 is to 6,000 is 3:2. So answer should be 3:2. But then the question is not giving me any such indication. Most likely in an exam, if such a question appears, everyone will get full marks because there was no indication that P will necessarily get a profit or whatever is being talked of here. Is very non-specific in terms of what is being asked. Next, company A has to act first by choosing a strategy and then Q will respond. Company Q has an advantage of knowing what strategy X has adopted. In such a situation, which strategy should company P adopt such that the advantage to company Q is the least? Okay. Advantage to company Q is the least. Advantage is defined as the sum of gain of company Q and loss of company P. Okay. See here, because I know the outcomes are happening in order, what I'm doing is I'm finding out the advantage here for company Q will be 5,200 and this, so 14,200. Here there is no advantage at all. Here there is an advantage of 19,400. Here there is no advantage at all. Here there is an advantage of 26,400. Here there is no advantage at all. Here there is an advantage of 25,000. Here there is no advantage at all. And here there is an advantage of 23,400. Now, if you are P and you're looking to minimize the advantage and you know that Q is making a move after you, Q is making a move after you. Of course, Q will make the move that benefits it the most. So which option should company P exercise so that it minimizes the advantage for company Q? Clearly, it is option A. And that is the entirety of the set. Question number 2, I don't know how that makes sense, or question 4, I don't know how that makes sense, but that is what this question is saying. That is what the OA is talking of. Let's look at this set. Total 20,000 students from 3 Indian states, Maharashtra, Karnataka, and Gujarat, who are studying in Ukraine and Russia have returned to India by 31st March 2022 under Operation Ganga as a result of the war in Ukraine. The number of students from Maharashtra, Karnataka, and Gujarat was 8,000, 7,400, and 4,600 respectively. Okay. We have total numbers available. These students study in 2 cities in Ukraine named Kiev and Donetsk, and 1 city in Russia named Smolensk. Some of these students have taken a bank loan for funding their studies, while the remaining are self-financed students. Of these 20,000 students, which is indeed the summation when you add up these numbers, 48% studied in Kiev, 37% studied in Donetsk, and the remaining 15% study in Smolensk. Okay. So now see, right now of the total 20,000, I know state-wise distribution also, and I know the 3 city-wise distribution also. Those numbers are straight away given. The following table shows the number of students from the 3 Indian states who study in 3 different cities who funded their studies through a bank loan. This is for people who have taken a bank loan. This is for people who have taken a bank loan. Okay. So now when Maharashtra has a total of 6,000, this directly implies there are 2,000 people who have not taken a bank loan. Karnataka has 2,400 people who have not taken a bank loan. Not that you write this down when you're reading it for the first time, but these are things that should come to your head. Okay, I know non-bank loan people in each of these groups. This should add up to 5,000. So yes, fine. So how to record this information that is given? It should ideally be recorded this way. Maharashtra, Karnataka,
and Gujarat, where if you know the totals, so I'm going 8,000 and 7,400. Gujarat is 4,600. These are the people with bank loan. These are the people no bank loan within Kiev, within Donetsk and Smolensk. Bank loan, no bank loan, bank loan, no bank loan. Bank loan people, I have the totals available straight away. 2,400, 2,400, 1,600, 6,400. For Kiev, I also knew there were 48% people. 48% people basically translates to 9,600 of 20,000. So there are 3,200 people here. Here it would be 3,000, 2,000, 1,400, and 6,400. And Donetsk had 37% people, so 7,400 people. So 1,000 here, non-bank loan people. Now here, what do I have? Gujarat or Smolensk, 600, 600, 1,000. So adds up to 2,200. And Smolensk had a total of 3,000 folks. 2,200 here, so 800 here. This table, this data was straight away there. Out of the students from Gujarat who have returned to India, the ratio of number of students who studied in Kiev to the number of students who did not study in Kiev is 10:13. Students in Gujarat was 4,600. Students who studied in Kiev and not studied in Kiev, if it is in the ratio 10:13, it is 2,000 is to 2,600. So there are 2,000 people from Kiev. 1,600 was already here. So this will be 400. Done. Moreover, out of all the students from Gujarat who studied in Smolensk, all students funded their studies through a bank loan. So Smolensk and Gujarat, there was nobody without a bank loan. So this is 0. Now, if I know total of the Gujarat row has to be 4,600, has to be 4,600. 4,000 people were already mentioned with bank loan, 400 people with no bank loan. So the remaining 200 people go here. This is uniquely identified. Cool. Next is the number of students of Maharashtra and Karnataka who studied in Kiev is equal. If number of people who studied in Kiev from Maharashtra and Karnataka is equal, these two numbers add up to same. If these two are identical, these two have to be identical. If this is 400, if this is 400, these two have to add up to 2,800, or each of them are 1,400. These numbers are identified, all the data points are done. Let us get to individual questions. First question was, if the number of self-financed students from Maharashtra who study in Donetsk and Smolensk is equal, these two numbers are equal. If these two numbers are equal, just see, 6,000 people were bank loan financed, so 2,000 more were needed, of which 1,400 are already used up here. So you'll get 300 and 300. These two numbers were equal according to the question. If the number of self-financed students from Maharashtra who study in Donetsk and Smolensk is equal, what is the total number of students from Karnataka who study in Donetsk? We need this number. We know this column has to add up to 1,000. This is 300, this is 200. So this should be 500. And now people from Karnataka who study in Donetsk would be 2,000 plus 500 or 2,500 in total. Hopefully you also notice the way I've written it in the corner with much smaller, because this is something that is valid only for question 1. When we move on to question 2, the first thing you have to do is erase this. This is no longer true. This condition was only valid for question 1. Next is, if the number of students from Karnataka who study in Donetsk is equal to the number of students of Karnataka who study in Smolensk, what is the number of self-financed students from Maharashtra who study in Smolensk? Okay, look at this. There were 2,400 people in total from Karnataka extra, from self-financed people. Let's call this self-financed people. 2,400 people from Karnataka, of which 1,400 are from Kiev. Now, 1,000 are left to be allocated. Even if all 1,000 of them went to Smolensk, can you see the summation of students from Karnataka who went to Donetsk and those who went to Smolensk cannot be equal? And therefore, the answer to the second question is, this situation is not possible. The constraint given in the question is impossible. Therefore, every subsequent bit of processing is useless. Okay, again, get rid of this. Ideally, if I was doing it in a notebook, I would not have the ability to erase this, so I would write it smaller, but okay. Next, what is the number of self-financed students from Gujarat who study in Donetsk? Self-financed students from Gujarat, non-bank loan people from Gujarat who study in Donetsk is 200. So option A. Which of the following can be the number of students from Maharashtra who study in Donetsk? They're asking number of students from Maharashtra who study in Donetsk. Okay. So let's say if this was X, they're asking for potential values of 3,000 plus X. Now column wise, can you see X has to be lower than equal to 800 column wise, because this column adds up to 1,000. 200 is already allocated here. Column wise, this should be equal to 800. But if you look at it row wise, this X also has to be less than equal to 600, because there are only 2,000 self-finance students, of which 1,400 are already allocated here. So what is left here has to be less than equal to 600. So between these two conditions, this is stronger. So the total number of students has to be less than equal to 3,600. Of the available options, there was only one such option. So the answer to question 4 has to be 3,550. The clue here, or something that you have to focus on, which of the following can be the number of students, which means you don't have to calculate it. You simply have to see if it is possible or not. That will be all for this set. Let's look at the second set. King Vikramaditya wants to build several palaces in Ujjain, the capital of his kingdom. Total building work required is 10,000 units for each palace. Okay. King Vikramaditya wants to complete building all the palaces in exactly 100 days. 10,000 units done in exactly 100 days. Right now itself is 100 units per day. This much work needs to be done. And the work completed every day is to be equal. Great. Further, the work on all the palaces is set to begin on an auspicious day next month. Cool. There are 3 types of workers available in the kingdom for the building of the palaces. They are as follows. Novice worker. Each novice worker completes work equal to 2 units every day. Okay. Skilled workers. Each skilled worker completes work equal to 5 units every day. Expert workers. Each expert worker completes work equal to 10 units every day. Okay. For every palace, we define a set N, defined as the number of novice workers, the number of skilled workers, and the number of expert workers. The number of workers of each type available in the kingdom for the work is enough to complete the entire work using only one type of workers. Okay. Basically, this last line, what this implies is you will never have paucity of workers. Workers are present in adequate number. You will always have enough number of workers present. Now, let's say you had N novice workers, S skilled workers, and E expert workers. Can you see that 2N plus 3S, sorry, not 3, 5S plus 10E has to be equal to 100. This is their efficiency per day. If there are N workers, 2 units every day, the amount of work they do is 2N. If there are 5 units done every day, there are S workers, amount of work done is 5S, and 10E, same storyline. Now, this equation here itself gives us a few clues. The first clue is this is even, this is even, and this is even, which gives me the result S has to be even always. The number of skilled workers you employ, the number of skilled workers you employ has to necessarily be an even number. The second idea you see is this is a multiple of 5, this is a multiple of 5, this is a multiple of 5. So now N has to be a multiple of 5. The number of novice workers has to be a multiple of 5, and the number of skilled workers has to be an even number at all times. These two inferences, very basic equation based, we can identify. Let's get to individual questions now. If the number of expert workers is to be more than the sum of the number of novice and skilled workers for building the king's palace, in how many ways can the set N for the palace be formed? We have 2N plus 5S plus 10E is equal to 100. Now, what I'm doing is the best case when I want the number of experts workers to be more than the sum of number of novice and skilled workers for building the king's palace, the best solution set that I can see is 10, 0, 0, 10, 0, 0. This is done. First, when I'm counting, I will hold the novice workers. I will not let the novice workers increase. I will only increase skilled workers and decrease expert workers. First case, I've identified this. Next case would be I can get this to 2, I can get this to 9. This will remain 0. Next case would be I can get this to 4, I can get this to 8. Next case would be I can get this to 6, I can get this to 7, 0. But I cannot increase this any further. I cannot increase this any further because the next case would be 8 skilled workers and 6 expert workers, which would be in contravention of the condition given. Number of expert workers has to be more than the sum of number of novice and skilled workers. So this is the ending point. This is the limit up to which you can count. The next case that I'm going to count, first I had held off the novice workers. Now I will hold off the skilled workers. I will not let skilled workers come into play. I have 10, 0, 0. Novice workers can only increase in steps of 5. So the next case would be 5, and this would be 9, and this would be 0. And I cannot go any further because the next possible case would be 10, 0, 8. And now novice workers have become more than expert workers. This is unacceptable. I can't have this. This is non-acceptable. I had held off the novice workers once. I had held off the skilled workers once. Then now the case is I will allow both of them to operate. The lowest possible case would be if novice workers are 5 and skilled workers are 2. 10 done here, 10 done here. Expert workers would be 8. Yes. Can any more change be possible here? Not at all. Because even if I reduce skilled workers by 1, they would become equal to novice and skilled workers. And now their number has to be increased in order to maintain the sum at 100. So these are the only cases possible. How many cases will there be? The answer is 6. Next question. If the number of skilled workers is to be more than the sum of number of novice and expert workers for building the Queen's Palace, and at least one worker of each type is to be employed, in how many ways can set N for the palace be formed? Okay. Look at it. 2n plus 5s plus 10e is equal to 100. I know I need at least one worker of each type, which translates to n has to at least be 5. N has to at least be 5. And this has to be at least 1. N has to be at least 5. E has to be at least 1. This is uniquely identified. 20 is done. So now this can be 16. This can be 16. Now, when I'm counting the subsequent cases, first case that I count, this is the starting point. This is the starting point. Or you can even go on to identify the starting point as this. You can even go on to identify the starting point as this 501. 20 units of work are done, and now I have to work in such a way, so on and so forth. I wouldn't recommend. I would say keep this as the starting point because this gives me a precise 100. I don't have to worry about it. Right now, I will let the number of novice workers be held. I will not let that number increase. I will let the number of expert workers increase or decrease. For every one expert worker increase, I need two skilled worker decrease. So the next case I see is 14, 5, and 2. Next case I see is 5, 12, and 3. Next case I see is 5, 10, and 4. And I cannot go any further because now see, the novice plus expert workers are 9. If skilled workers go down, they will become 8. That is not possible. So we have found 4 cases. Cutoff point. So far we had tried to stop only we had stopped the novice workers from increasing, and we were only working with expert workers. The other case would be stop the expert workers and let the novice ones increase. Base case is 5, so next case would be 10. So this would be 14 and 1. 2 into 10, 20, 10 into 1, 30, 5 into 14 gives me happily what? Gives me 14 is greater than 11. So this is an acceptable case. But I can't go to the next one. Next case would be 15 and 12 and 1. I cannot go any further. This is unacceptable because the number of skilled workers is now smaller than the number of novice and expert workers. So I can't count any further. Why can't I get eraser? Okay, this is also identified. Now for the third case, let me increase the novice workers also and expert workers also. If I increase the novice workers, they would become 10. If I increase the expert workers also, this would be the smallest case. This goes from 5 to 10. This goes from 1 to 2. 20 gone here. 20 gone here. We are left with 60. This is an unacceptable case because we want the number of skilled workers to be more than the novice and the expert workers. Here they are turning out to be equal. Even in the smallest case, if they're turning out to be equal, I can confidently say that there will be no more further such cases. So how many total cases do I get? I get 5 total cases. Let us go to the next question. If the king wants to employ no more than 100 expert workers for the construction of the work of the palaces, and if the number of expert workers is to be more than the sum of number of novice and skilled workers for each palace, what is the maximum number of palaces that can be built? Now see, this question is an offshoot of question 1. This is an offshoot of question 1. Question 1, you had to count all those cases where the number of expert workers were more than the number of skilled and novice workers. Now we want the case where no more than 100 expert workers are hired. At the same time, you want maximum number of castles to be built or palaces to be built. If you want maximum number of palaces to be built, wherein and also you have a limit on the number of expert workers that can be hired, can you see the best case would be where your number of expert workers hired per palace, your number of expert workers hired per palace is the lowest. In which of these cases is the number of expert workers hired per palace is lowest. Of course, this is the case. So for one palace, you would end up needing 7 expert workers. Given that you have 100 expert workers, how many groups of 7 can you take out? 100 by 7. You will get 14 complete groups, or 14 complete palaces can be made. The remaining 2 expert workers will be sent home. Nothing more doing. Answer to the third question is B, and this is a direct offshoot of question 1. Next, suppose at least one skilled and at least one expert worker is to be employed and no novice worker is to be employed. So in our equation, plus 5s plus 10e is equal to 100. At least one skilled and at least one expert worker is to be employed and no novice worker is to be employed on the Princess Palace. And the total number of workers to be employed on that palace is to be 20. In how many ways can the set n for that palace be formed? We know this n to be 0. If all these 20 workers were skilled, then I would get 100. If all these 20 workers were skilled, then I would get 100. But in this case, expert would be zeros. But I was told there has to be at least one expert worker. If there is at least one expert worker, can you see? If I shift one person from the skilled group to the expert group, total increases by 5, and you cannot maintain a total of 100, which means no such case is possible. You cannot possibly make a case that way. And the answer to this question has to be option A. Has to be option A. In how many ways can set n for the palace be formed? 0. Next is, suppose exactly 10 novice workers and at least one skilled and at least one expert worker have been employed on the military chief's palace. In how many ways can the set n for that palace be formed? Okay. Let's see. I have exactly 10 novice workers. If exactly 10 novice workers are there, can I say 20 units of work is done? So I now have 5s plus 10e is equal to 80 directly. And both of them are there. At least one skilled and at least one expert worker is there. So can I say 2 skilled workers have to be there? First, minimum case would be when 2 skilled workers are there, 10 gone. This would be 7. This would be 7. And now every subsequent case would be 4, 6, 6, 5, 8, 4, 10, 3, 12, 2, 14, 1. How many cases in total? In how many ways can the set n for that palace be formed? 2n is fixed. If I include 2n, then I have to make sure the total is 100. This is 10 in each case. How many different sets can be formed? There can be 7 different sets formed. Next, suppose King Vikramaditya wants to build total 10 palaces subject to the following requirements. On 5 palaces, the number of expert workers employed is more than the sum of the number of novice and skilled workers. Okay. Hopefully, this reminds you of question 1 again. These cases were counted in question 1, which are helping us right now. On the remaining 5 palaces, the number of novice workers employed is more than the sum of number of skilled and expert workers. Okay, n is greater than skilled plus expert in these 5 palaces. What would be the total number of expert workers employed on these 10 palaces if the total number of workers employed is to be minimized? If you want to minimize the total number of workers, your target should be to maximize number of expert workers, because if the expert workers are more, their individual efficiency is the highest. Greater the number of expert workers, lower the total number of workers. So for this case, for let's call this situation 1 and 2. For situation 1, the best possible scenario would be 5s plus 10e is equal to 100. Best possible scenario would be 10, 0, 0. You are minimizing the total number of workers. And for scenario 2, let's see, 2n plus 5s plus 10e is equal to 100. What I now want to do is I have to ensure that n is greater than s plus e. At the same time, I want e to be as large as possible. So if this is the starting point 0, 10, 0, can I go here 10, 0 and 8, 10, 0, 8? This would be wonderful. This would be acceptable. Now the number of novice workers is greater than the number of expert workers. Everything works out well. There were 5 such instances, so I get 50 expert workers from here. There were 5 such instances, so I get 40 workers from here. Altogether, what would be the total number of expert workers employed on these 10 palaces? Answer would be 40 plus 50, or 90 would be the final answer to this set. This set takes a lot of time in explaining. It does not take a lot of time in solving, because this set is basically about counting it the right way. If you can break it down into cases and count appropriately, everything will flow fairly smoothly. That will be all for this set. Let's look at this set now. 10 individuals named A, B, C, D, E, F, G, H, and I and J live in a 6-floored building numbered 1 to 6 from the bottom to the top. Following points are known. Okay. On each floor, 1, 2, or 3 individuals live. Okay. So 1, 2, 3, 4, 5, and 6. Only B and J live on the first floor. So on the first floor, I only have B and J. Okay. A lives on a higher floor, that is a floor with a higher number than C, who in turn lives on a higher floor than D. Moreover, there is exactly 1 floor between A and C. So there is A, there is a gap, there is C, and then there is D. C and D could be consecutive floors also. C and D could potentially have some gap also. We don't know. Okay. E and F live on the same floor. EF live on the same floor. They are guaranteed to be together. The number of individuals who live on each floor is not equal to the number of individuals who live on any adjacent floor. That means the number of individuals who live on the 5th floor is not equal to the number of individuals who live on the 4th floor, or the number of individuals who live on the 6th floor. Okay. So I am saying if we were making cases about how many people live on each floor, how many people live on each floor, we know that 2 people live here. This is fact, because this data was given to us. Only B and J live on the first floor. That is fact. We don't have to worry about it. But I know this floor cannot be 2, so on and so forth. The fun thing is, where this set cracks or opens or becomes solvable is, first thing you have to see, there are 6 floors in total. Let's say floors with 1 occupant, dx, and floors with 2 occupants, dy, and floors with 3 occupants, dz. So x plus y plus z is equal to 6, count of total floors. Additionally, we also have the number of people. Number of people is 10. So x plus 2y plus 3z. This is count of floors. This is number of people on all the floors combined, is equal to 10. If I solve these two equations appropriately, or if I solve them simultaneously, x and x gone, y plus 2z is equal to 4. Why? plus 2z is equal to 4. Now I know that y has to be greater than equal to 1 because number of floors on which two people live, one such floor is already identified. Floor 1 where B and J live, two people are already living there. So I can either have one here and one here. Sorry, one floor here. Sorry, one cannot work here. I am extremely sorry. Y has to be greater than equal to 1. Or also, according to this equation, this y has to be even. So the smallest possible case is y is 2 and z would be 1. Y equal to 2, z equal to 1. The next possible case would be y equal to 4 and z equal to 0. But then this is an impossible case because we were told the according to point 5, the number of individuals who live on each floor is not equal to the number of individuals who live on any adjacent floor. There are only 6 floors. If four floors have two occupants, at least one pair among them have to be adjacent to each other, and that is not allowed. That is not allowed, which means this is an unacceptable case. So at this time, we know number of floors with two occupants has to be 2. Number of floors with 3 occupants has to be 1. And number of floors with 1 occupant now has to be 3. These 3 counts of floors with how many occupants is uniquely identified. Now, if the number of floor with 1 occupant is 3, it has to either be on floor 1, floor 3, floor 5, either this grouping so that they are not adjacent, or the other grouping has to be 2 or 4 or 6. It cannot be 135 because floor 1 already has 2 occupants. This is floor number, this is occupants. We already have uh, 2 occupants in 1, so 135 is not possible. The only way it works is if I have 1 occupant here, 1 occupant here, and 1 occupant here. Now 5 and 3 can either have 3 occupants or 2 occupants. Can either have 3 occupants or 2 occupants. So what I will do at this time is I will have 2 occupants here and 3 occupants here, and go ahead and create a separate table. Floor number and occupants. Let me write down all the information that I already have. 4, 5, 6. I have 2 people here. I have 1 person here. I have 1 person. Sorry, I have made a mistake about 1 person's in the second representation. It has to be 1 person here, 1 person here, and 1 person here. And now this should be 3 and this should be 2. Now, next game that I have to see is, I remember A had to be 1 floor ahead of C. So case wise, what I can potentially have is, I can have A here and C here. But when A is here, C is here, D can be at 2 different floors. So I can have A here, A, C, and D. These 2 cases are possible. The other case I can have is A here, C here, and D here. This is uniquely identified. Okay. Now let's go. Now, where can I go? Okay. Now for this case, first one, I'm calling this case one. Case one. The next bunch of people that I want to fix, is ENF. ENF can come in floor 5 and ENF can come in floor 3. So if this is 1, I'm going to create this as 1A and this as 1B. I can have EF here, or I can have DEF here, A here, C here, BJ here. This 1A and 1B mark is important so that you remember what all has to be copied. Now, the only people who are left are G, H, and I. G, H, and I. These are the only three people left. Mm, Those three people, in this case, they have to come in these three spots. So can I say I will get three total cases from here? Three total cases from here. G, H, I, wherever they want to go. Here, they will have three different spaces still left for them. So I will again get three cases from here. 1A gives me three cases, 1B gives me three cases. Okay, next is this one. 2, 1 is here, C is here, D is here. Again, can you see with ENF? With ENF, you can have two cases. So you would have to make 2A. This time I'm not even changing color. I would have to make 2B. Now, EF can go here, or EF can go here. So A copied, C copied, D copied, and now I have BJ here. BJ is same everywhere. Why am I not putting it down? Okay. So now the three spots that are left are these GHI, and here three spots that are left are these. So one case from here and three cases from here. For this third case here, can you see EF? There is just one spot where EF can come. There is just one spot where EF can come. It has to be on floor 3 where there are three people, because EF cannot come on floor 5, two people. One of those spots is already occupied by A. So it has to be EF here, EF here. Now three spots are left. These three spots, GHI, have to come. They can come here in 3 factorial ways. So we get a total of 6 cases here. So I've got 3, 1, 6, 3, 3, a total of 16 cases from 1, 2, 1, 3, 1, 2. Now, if you were smart, or you were able to see it, even if you were to shift it around, 3 and 2, your count of cases is not going to change. You're also going to get 16 cases from the right hand side also. You're also going to get, because it doesn't really matter which grouping you're shifting where and everything, it will still be 16 cases on the right hand side. But of course, we want to be sure that we've counted it appropriately. So we'll go ahead and do that. DJ we've got here. First point of counting is A here, C here, D here. Next point of counting is A here, C here, D here. Next point of counting is A here, C here, and D here. Let me break it up this way. I've gone to 1, 2, 3. So let this be 4 now. This is 4 now. Now EF has to go somewhere. EF can only go here. So there is one blank left here, one blank left here, one blank left here. I will get 6 cases. Next, EF can go at 2 places. So if this is 5, I need a 5A. This is 5A, this is 5B. EF can go here and EF can go here. A, C, D. I completely forget getting these folks. Now the spots left are 3 spots here. So there is just one case from here. Here I have 1 spot left and 2 spots left. So I have 3 cases from here. Okay. EF for EF in case 6. EF in case 6 can only go at 1 spot. It cannot go on floor 6. It can only go on floor 5. So EF is fixed here. It cannot go on floor 3 because C is already occupying one of the spots. So there are 3 spots left, 1, 2, and 3. You get another 6 cases from here. 6 plus 3 plus 6 plus 1 adds up to 16. We have identified all the possible cases. In hindsight, of course, hopefully you can appreciate this is far too painful to be successfully accomplished within the constraints of a timed environment. But after the test, of course, you should be in a position where you're looking at it and seeing how the counting should have taken place. First question, how many arrangements for the given 10 individuals and the floors they live on can be generated? Answer is 32. Second question, suppose G and I live on the 5th floor. G and I live on the 5th floor. Okay. Can I have a case where G and I live on the 5th floor? I can have 1B and 2B where G and I are living on the 5th floor. And I can have 5B where G and I live on the 5th floor. Both E and F live on the 3rd floor. In 5B, yes. In 2B, yes. In 1B, yes. This is true. H lives on the 5th floor. Not necessarily in 1B and 2B. That is not necessarily true. So statement 1 is definitely true. Statement 2 is not definitely true. So has to be this. Only 1 is necessarily correct. Next statement, consider the following statements. C and H live on adjacent floors. Okay. D and H live on adjacent floors. What can be said about these two statements? Both 1 and 2 are necessarily correct. Only 1 is necessarily correct. Only 2 is necessarily correct. Neither 1 nor 2 is necessarily correct. Look at case 3. Look at this case. Can I have a situation where I have H here, G here with A, and I here? Is H adjacent to C? No. Is H adjacent to D? No. So, can I happily go on to say neither 1 nor 2 is necessarily correct? Answer has to be option D. I don't know if you can see option D clearly, but that is the answer. Okay, next question. The floor numbers of how many of the 10 given individuals can be uniquely identified? Okay, we know B and J. For those 2 people, we definitely have the count. 2 people, we definitely have the count. C, do I have it on different? A, do I have it on different floors? Yes. C, do I have it on different floors? Yes. D, do I have it on different floors? Yes. E, do I have it on different floors? Yes. F, do I have it on different floors? Yes. GHI, can I have it on different floors? Yes. So these are the only 2 people. B and J are the only 2 people whose floor numbers can be uniquely identified. Answer to the 4th question has to be 2. Next, additional information for question 5 and 6. There is exactly 1 floor between C and D. What that helps us with is, if there is exactly 1 floor between C and D, if there is exactly 1 floor between C and D, can you see this case is no longer valid? I will not erase it entirely but let me mark all those. This case is definitely valid now, or this is the case that is left. 1A is not valid, 1B is not valid. If 2A and 2B are valid, C and D have 1 person in between them. 3 is not valid, 1B is not there. Also, 5A and 5B. These are the 4 cases that are valid now. There is exactly 1 floor between C and D. How many arrangements for the given 10 individuals and floors they live on can now be generated? Here I had 1, here I had 3, Here I had 3. Here I had 1. So altogether, I will get my answer as 8 for question number 5. 3, 1, 3, 1. The floor numbers of how many of the 10 individuals can now be uniquely identified. Okay. Let's look at the floor numbers of the 10 individuals. A, 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 A. B and J were already fixed. A is also fixed now. C, 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 C. This is irrelevant. And D, 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 D. Okay. A, C, D, B, J, their locations are fixed. GHI can switch with EF. So the answer to the last question has to be 5. This is indeed a painful set, especially because in order to arrive at the appropriate answers, you need to go through counting of everything. It will take time, it will take effort. It is not, most likely, I would not attempt this in an exam. At the same time, after the exam, devoting some time to it in order to learn how the counting should have taken place will be beneficial for us. That will be all for this set. Okay. Jesse, George, Kenneth, Milton are 4 male students, while Jessica, Ginger, Kenna, and Minda are 4 female students who are attending the annual conference of the American Economic Association. 3 of these 8 students are from Harvard, 3 others are from Cornell, while the remaining 2 are from Princeton University. Each of these 8 students carry passports issued by 2 countries. One issued by their country of birth, called primary passport, and the other issued by another country that has granted dual citizenship to these students, called secondary passport. Each of these 8 students has a primary as well as a secondary passport from one of the following 3 countries: US, Canada, or UK. So, attributes wise, we have name, we have gender, we have university, we have primary passport, and we have secondary passport. These are the 5 things that have to be distributed among these 8 people. Okay, let's do that. Name, gender, university, primary, and secondary. Let's make an appropriate table. Two, three, 4, 5, 6, 7, and 8. Okay. No 2 students from the same university have the same initials. So now Jessica and Jesse are from different universities. George and Ginger are from different universities. Kenneth and Kenna are from different universities. Milton and Minda are from different universities. Okay. There is no male student out of the given 4 in Princeton University. So, can I go female, female, Princeton? Because we were told that 2 are from Princeton University. Princeton, 2 female identified. The other 2 universities have at least 1 male as well as 1 female student. So, given there are 4 males and 2 females left to be distributed, I can happily say male, male, female, and male, male, female. This is Harvard. And this is Cornell. Okay. Both the male students from Harvard University have their primary passport issued by the US. So US, while the female student from Harvard University has her secondary passport issued by Canada. Female Harvard secondary passport is Canada. No other male student has his primary passport issued by the US, and no other female student has her secondary passport issued by Canada. So US not, Canada not, Canada not, Canada not. Okay. Only one male student has his secondary passport issued by Canada, while 3 female students have their primary passport issued by Canada. If 3 female students have their primary passport issued by Canada, those 3 female students have to be the 2 from Princeton and 1 from Cornell. So Canada, and Canada. This is done. Okay. Only one male student has his secondary passport issued by Canada. Secondary passport issued by Canada. We will see this part is still left. All the students who have their primary passport issued by UK have their secondary passport issued by US. So we know if we see UK in primary, US has to be secondary. US has to be secondary. Okay. The number of students who have their primary passport issued by US, Canada, and UK are 3, 3, and 2 respectively. US has 3 people. Primary passport US are 3 people. Not from Princeton, not from Cornell. So can you see the female from Harvard needs to have her passport issued by US, primary passport issued by US, because there are 3 people who are from US. From Canada, 3 people need their primary passport. So 2 females from Princeton are identified. 1 female from Cornell is identified. That is also done. So the 2 people or 2 males from Cornell will necessarily have their primary passport from UK. And as soon as they have it from UK, their secondary passport has to be from US. These numbers are 3, 2, and 3 respectively for their secondary passports. 3, 2, and 3 respectively for their secondary. So US has 3 secondary passports. US has 3 secondary passports, of which 2 are already identified. Canada has 2 secondary passports, of which 1 is already identified. And UK has 3 secondary passports, of which none are currently identified. So 1 left here, 1 left here, 3 left here. Okay, I will see later. Oh, UK has 3. I will see it later, who or what it is. Jesse and Ginger are from same university. Jesse and Ginger. So Jesse and Ginger are from same university, while similarly George and Jessica are from the same university. Okay. So Ginger and Jessica, 2 females. These are the females who have to be from Harvard and Cornell. Jessica and Ginger have to be 2 females who are from Harvard and Cornell, because they are paired up with males in some university. So Kenna and Minda are uniquely identified from Princeton. This is Kenna. This is Minda. We are able to write these down as well, because so far both these people have same pieces of information, nothing different. Okay. George, whose primary passport has been issued by the UK. So George has to be from Cornell. George is from Cornell, and George was in the same university as Jessica. So this has to be Jessica. Now the only female left is Ginger. 1 minute, people. Okay. So Jessica is here. Ginger is here. And Ginger was in the same university as Jessie. The only two people left are Kenneth and Milton. So either this is Kenneth or Milton. Kenneth or Milton. We'll see. Okay. George, whose primary passport has been issued by the UK, is not from the same university as Jessie. Okay. George and Jessie are from different universities. That is identified. Now, the only thing left for us to take care of is this is done. Only one male student has his secondary passport issued by Canada. Okay. So one of these two people has his secondary passport issued by Canada. So UK has 3 people. Let's say Jesse was from Canada, or this other fellow had his secondary passport issued from Canada. Either this was Canada or this was Canada. Now the US fellow has to be at one of these 3 spots, because whoever is left here cannot be US. So this person has to be UK. So the 3 blanks have to be 2 UK and 1 US. Similarly, 1 blank here, 2 blanks here. Sorry, this person here. In the second case, Jesse needs to have his secondary passport issued from UK. Again, 2 UK and 1 US left. We don't have precise distribution for secondary passports, but everything else we know precisely for every individual. We know precisely for every individual. In fact, let me mark them with a separate color just to show you where we have non-confirmation. Okay, let's get to individual questions. First question, consider the following 2 statements. All the 3 students from Harvard have their primary passport issued by the same country. Yes, this is true. All 3 of them have their primary passport from US. This statement is valid. All the 3 students from Harvard have their secondary passport issued by 3 different countries. No, 2 of them have their secondary passport issued by Canada and 1 by UK. So the second one is not definitely correct. So what can be said about these statements? Only statement 1 is definitely correct, while statement 2 is definitely incorrect. Answer has to be option C. Next, if both the female students from Princeton have the same combination of primary and secondary passport, what can be said about the primary passports of the 3 students from Cornell University? This is a fun question because can you see we have the precise information about the primary passport. It doesn't really matter whether the female students from Princeton have the same combination of primary and secondary passport or not. So we know the 2 males have it from UK and 1 female has it from Canada. So out of the 3 students from Cornell, 1 student each has his primary passport from US, UK, and Canada each. No, this is false. Out of the 3 students from Cornell, 2 students have their primary passport from UK, and a third student has his or her primary passport from Canada. Yes, this is true. This third one is untrue because 2 students don't have it their primary passport from US, And the fourth one is incorrect because nobody has it from US. So answer to the second question is option 2. Third question, if two female students from Princeton have different combination of primary and secondary passport, what can be said about the secondary passport of three students from Cornell University? If they have different combination, primary is same. If they have different combination, that can only be possible if one is UK and one is US, one is UK, one is US, in whichever order, doesn't really matter. But now it is guaranteed Jessica will have UK as her secondary passport. Jessica will have UK as her secondary passport. So two have got their secondary passport in Cornell from US and one from UK. So option 3. Out of the 3 students from Cornell, 2 have their secondary passport from the US, and the third student has his or her secondary passport from the UK. Third option is true. Last question, which 2 female students are from Princeton? The 2 female students from Princeton are Kenna and Minda. Kenna and Minda, yes, the option B. And that is all that you had to engage in for this set. That will be all. Let's look at this set. 8 students, Anita, Bharat, Carla, Davis, Arvind, Frida, Gautam, and Hina, wanted to purchase a ticket for a mathematics lecture. The tickets were allotted on first come, first serve basis. The students arrive at different times and form a queue in front of the ticket counter. The price of a ticket is rupees 110. When a student gets to the counter, the ticket is immediately generated and provided to the student. But it takes 5 minutes to generate the receipt. Okay, so you get to the counter, the ticket is immediately handed to you, but the receipt, the bill, is handed to you 5 minutes later. Okay, and the price of the ticket is 110. You have to keep these points in mind for subsequent processing that you engage in. After collecting the ticket, the student has to wait and collect the receipt from the counter before the next student can approach the counter to collect his or her ticket and receipt. Okay, therefore, no ticket is booked while a receipt is being generated. So if a ticket is booked, the next ticket can be earliest booked after 5 minutes. Earliest it can be booked after 5 minutes, nothing more than that. Okay. A student pays rupees 5 less for every minute he or she waits in the queue till he or she gets the generated ticket. For example, if Anita joined the queue at 10:10 and she gets to the ticket counter at 10:15, she pays rupees 25 less. Okay, so for every minute you wait, you pay 5 rupees less. So out of 110 rupees, if you waited for 5 minutes, you pay 25 less. That is, you pay 85 rupees. Okay. If Arvin is immediately after Anita in the queue, then he gets his ticket at 10:20. Okay. Okay. Every student arrived exactly at the start of a minute. Every student gets the ticket and receipt at the end of a minute. No two students joined the queue at the same time. Okay, so there is a precise order. Everybody is joining at a separate time. So there are several parameters that you have to take care of. One thing is, of course, name. Then there is the time you join the queue. The time you join the queue. Then when you get your ticket. Then when you get your receipt. Then when you get your receipt, and finally the bill that you have to pay. These are the 5 things that we have to capture for how many people? 8 people. Okay, so let me just make a table with all these columns. There are 8 students, so 8, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, this much is known. Let's read. The ticket counter opened at 10 and Davis was first in line, arriving at 10. Okay, so Davis is the first person in line and he joined at 10 and ticket counter is also open at 10. So he will get his ticket at 10 itself. But in order to get his receipt, he will have to wait till 10:05 because it takes 5 minutes to generate the receipt. And his bill will be the entirety of 110. He has not waited for even a single minute. He will have to pay his entire bill. The charge that he has to pay is 110. Okay. This point you have taken care of. Next is one student joined the queue at 10:25. Okay, we'll see. This doesn't really help me in any way right now. I don't know when people are joining, so I will take care of this later. Next is Arvind was the last student in the queue and paid rupees 90. Okay, Arvind is the last student in the queue and he paid rupees 90. If he paid 90, he paid 20 less, which means he waited for 4 minutes. So I am writing 4 this way. The difference between him joining the line and getting the ticket is 4 minutes. This much I know. What precise time did he get his ticket? What time did he join the line? That I don't know. But I know the difference between those two is going to be 4 minutes. Okay, this is also recorded. There were exactly 2 other students in the queue when Gautam collected his receipt from the ticket counter. Okay, so when Gautam collected his receipt, there was somebody and somebody else present in the counter. Okay. For all other students, there was exactly 1 other student in the queue when they collected the receipt. This is wonderful. See, this line, along with the first part of this, gives me something very interesting. One, the fact that there was always a student waiting, there was always a student standing in the queue when the receipt was being collected. It means the next ticket generation happened almost instantly. So let's say Davis was getting his receipt. At that time, somebody was already waiting. So that person will get his ticket at 10:05 straight away. That person will get his ticket at 1:05 straight away. Sorry, 10:05 straight away. Similarly, whichever person is standing at the second spot, he will get his receipt at 10:10. This person will get his ticket at 10:05. He will get his receipt at 10:10. Whoever this person is, when he is getting his receipt at 10:10, somebody was already standing in the queue. So that person will get his receipt, that person will get his ticket at 10:10 instantly. Receipt generated, next ticket is generated instantly. This is why we were also told ticket is immediately generated. So the timings are going to be one after the other because there was always somebody who was standing in the queue. Had there not been somebody standing in the queue, then we can't say what is the gap between the generation of subsequent tickets. But because there was somebody always standing in the queue, as soon as the prior person takes the seat, the subsequent person will get the ticket. So I can happily fill up the time straight away here. 10:15, 10:20, 10:20, 10:25, 10:25, 10:30, 10:30, 10:35, 10:35, and 10:40. These are known. Now, can you see information one person joined the queue at 10:25? That we can't really state right now. We'll take care of it later. We'll take care of this later. But from the second line, we know that the joining times, the ticket generation times, and the receipt times are going to be precisely these. Additionally, we knew Arvind had to wait for 4 minutes before his ticket was generated. So he definitely joined at 10:31. He definitely joined at 10:31. One more thing that we know from the fourth point, Gautam, when he collected his receipt, there were 2 people waiting in the queue. Now look at this person. Whichever person is waiting or after Gautam, the second person after Gautam. Can you see this person will wait 5+ minutes? This person will wait 5+ minutes because not only was this person waiting when Gautam was taking his ticket, that person will also have to wait for the entirety of the prior person getting his ticket. So this person is of course going to take a 5-minute duration, and whatever time was there that he was waiting while Gautam was getting his receipt. So the second person after Gautam has to wait for 5+ minutes. Okay. And the fact that this is the only person who will get 5+ minutes because for all other students, there was exactly 1 other student in the queue when they collected the receipt. The other people are waiting for 5 or less than 5, but there is exactly 1 person who's waiting for more than 5 minutes. This is informed to us via point 4. Next is the amounts paid by Anita, Gautam, and Carla form an arithmetic progression in that order. And all 3 of them waited in the queue for at least a minute before getting the ticket. Okay. Now see, Anita, Gautam, and Carla. All of them form an arithmetic progression in that order. The bills paid by them. The bills paid by them form an arithmetic progression, which would mean the times for which they had to wait also had to be in arithmetic progression, because the bill is going to be 110 minus wait time for Anita, 110 minus wait time for Gautam, and 110 minus wait time for Carla. If these three numbers are in AP, can I say WA, WG, and WC also have to be in AP in that order? So this person is guaranteed, as in this is the middle term. Now I don't know wait time for Anita is larger or wait time for Carla is larger, but we will see. We will take care of this later. Okay. We cannot tick off 5 because we haven't really utilized it right now. Okay. Next person is Frida was the 5th person. Oh, oh, one more thing, one more thing, one more thing, one more thing. Oh, we know something fun here. See, uh, from this, one student joined the queue at 10:25. If a person has joined the queue at 10:25, could he have joined the queue at 10:25 in this spot, in the 6th spot? If that person joined the queue at 10:25, then for the last person, no one was waiting in the queue. No one was waiting in the queue when that person was getting his receipt. So the 6th person cannot be joining at 10:25. Did this 8th person join at 10:25? No. For Arvind, we already know he joined at 10:31. So the only person who joined at 10:25 has to be here. And this person has waited for 5 minutes. So the bill payment by him has to be 85. This is also taken into consideration. This is awesome. Point 2 is also gone. Okay. Next point is Frida was the 5th person to get the ticket. So 1, 2, 3, 4, 5. This is Frida. Frida was the 5th person to get the ticket and paid 75. If Frida paid 75, this is 35 less than the ticket price, which means Frida waited for 7 minutes. Now look at point 6 in conjunction with point 4, first part. There was only one person who was supposed to be 5 plus minutes, no? And this person was supposed to be 2 spots after Gautam, which means Gautam is definitely here. Additionally, Frida joined the queue at 10:13. Now see, Gautam got his receipt at 10:15. Frida was waiting at that time. Then whichever person came after Gautam, that person did whatever he had to, and then Frida did whatever she had to. Okay, this is also done. Next is, this is also done. No. 5th is not done. I'm so sorry. 5th is not done. 6th is done. Point 6 is done. No other student waited longer than her. Yes, we know that for certain. Next, the total amount collected from the 8 students was 745. If the total amount collected was 745. Now see, total bill collected, had there been no penalty for delays, would have been 880. But the fact that 745 is being collected means 135 of revenue is being lost on account of delay. And for every minute of delay, 5 rupees is lost. So 135 divided by 5. Can I say there was a grand total of 27 minutes of delay? There was a grand total of 27 minutes of delay. Now, of this 27 minutes, we already know Frida waited for 7. We already know Arvind waited for 4. These two numbers we already know. Rest we will see. Okay. There were exactly 3 students who got the ticket after Anita and before Bharat. Okay. So Anita, can she be 1? No. Can Anita be 2? If Anita is 2, 2 Anita, 3, 4, 5, and 6 is Bharat. Second spot and 6th spot is empty. Let me name these spots so that it is easier to see. 2 and 6 is empty. 3 and 7 wouldn't work. 4 and 8 wouldn't work because 8 spot is already as Arvind. So the only spots where Anita and Bharat are coming can be 2 and 6. So Anita is for sure here and Bharat is for sure here. Okay. So this is also taken care of. Next is Bharat and Hina waited for 5 minutes in the queue before getting the respective tickets. So this is done. Bharat waited for 5 minutes. If he waited for 5 minutes, he joined the queue at 10:20 and he paid 85 rupees. This is also uniquely identified. Okay. And Hina also waited for 5 minutes. Now remember, the wait time for Anita, Gautam, and Carla was supposed to be Nepi. We already have Frida, Erwin, and Bharat 7, 4, and 5. 7, 4, and 5. This is equivalent to how much? 7, 4, and 5 is equivalent to how much? 16. 16 is already gone. 11 is left. Now, because 11 is left, I am saying, okay, let's see. Hina waited for 5 minutes. If Hina waited for 5 minutes, I don't know where Hina is, but if Hina waited for 5 minutes, can you see the three people left are Anita, Gautam, and Carla? How much is left for Anita, Gautam, and Carla? 6 is left. And all three of them waited in the queue for at least a minute before getting a ticket. Because these three are in order, can I say wait time for Gautam? Because the summation is 6. The middle term will, of course, be 2. Wait time for Gautam is, of course, 2. For Anita, it will either be 1 or be 3. And for Carla, it will either be 1 or be 3. Or let me write it this way 3 1 or 1 3. Now, because Hina is the only person, see, the seventh person is unknown, but they had a 5-minute wait time. That can only be Hina now. Hina is most definitely here. Once that is taken care of, the fourth spot is the only one left where the person is not mentioned. So this will be Carla now. Now for Gautam, we know the delay is 2 minutes. So he joined the queue at 10:08. This is also known. And the payment that he will make will be 100 rupees. Now the last point. The second person to get the ticket waited for less time than the fourth person to get the ticket. Anita waited for less time than Carla. So wait time for Anita is 1. Wait time for Carla is 3. 1, 2, 3 is guaranteed. So Anita must have joined the queue at 10:04 with a wait time of 1. And Carla must have joined the queue at 10:12 with a wait time of 3. And now the bill for Anita will be 105. The bill for Carla will be 95. We have the precise times everybody has joined. We have the precise times everybody has waited. Then they got the ticket, when they got the receipt, what the bill they paid, everything is known. Let's get to individual questions. When did the last student join the queue? It was Arvind at 10:31. At what time did Gautam join the queue? Gautam joined the queue at 10:08. So option B. How many students got tickets before Bharat? Before Bharat, 5 students got their tickets. So option C. Who was the seventh person to receive the ticket for the lecture? Seventh person was Hina. So again, option C. At what time did Bharat collect the receipt from the counter? Bharat got his receipt at 10:30. Option C. And question 6. Which of the following is true? Anita joined the queue at 10:02. No, she joined at 10:04. Frida joined the queue at 10:12. No, she joined at 10:13. Anita collected the ticket at 10:10. No, Anita collected the ticket at 10:05. She collected the receipt at 10:10. Frida collected the ticket at 10:20. Yes, Frida did indeed collect the ticket at 10:20. So option D, and that is the entirety of this set. Let's look at this set. ABC school conducted a test for the students of class 11. Okay. All the students in the class attended the test. The test had 4 sections: accounts, business maths, commerce, and economics. After the results are announced, the students who failed in 2 or more sections were asked to retake the test. Okay. The following is known. This is a 4-set Venn diagram question. Nothing too fancy about it. Simply make a 4-set Venn diagram and work. But this is too high, or let it be. Who cares? The biggest skill involved here is making the diagram. What are the 4 subjects? Accounts, business maths, commerce, and economics. Okay. 20% of the students who took the test failed in all 4 sections. So whatever I get here, 20% will be outside. If 20% is outside, 80% is mentioned inside. Okay. 120 students passed in economics and 105 passed in business maths. So 120 here and 105 here. Okay. This is done. 20% I will take care of right at the end. The number of students who passed only in accountancy. So this region is same as the number of students who passed only in economics. So this region, which is 10 less than the number of students who passed in all 4 sections. Okay. So this is A, this is A, this is A plus 10. Okay. 15 students passed only in commerce. So 15. Why I'm writing these variables small is so that at a later point when I get to the precise number, I can write it in big font so that viewing is easier later. The 15 students passed only in commerce, and this is equal to the number of students who passed only in commerce and economics. Only in commerce and economics is also 15. So this is also 15. Okay. 5 students passed only in business maths, which is equal to the number of students who passed only in business maths and economics. Only business maths and economics is given here. So this is 5. 0.4 is very, very helpful. It gives us precise info about everything that we need. Okay. I'll take a pause because my drawboard seems to be getting stuck. Okay. I'm back from that pause. It is working now. 0.4 is helpful because it is giving us precise data points for different regions. 0.5. The number of students who did not pass only in economics. So if you are not passed only in economics, you are passed in everything else. The number of students who did not pass only in economics is 1/6 the number of students who passed in all 4 sections. All 4 sections was A plus 10. Now you can go ahead and write it as A plus 10 by 6, or you can write it as if this is 6y, this is y, this would be simpler to manage. This is 6y, this is y. Okay. 5 students passed in all sections but accountancy. So overlap of business maths, commerce, and economics is 5. So this here is 5. Okay. 0.5 is also done. 0.6. The number of students who passed only in commerce and business maths is 20. Only commerce and business maths is 20. This is 20. The number of students who passed only in accountancy and business maths is 25. Okay. This is 25. 0.6 is also very helpful. 0.7. The number of students who passed in all 3 sections but commerce. All 3 sections but commerce. As in, apart from commerce, you're passing in everything else, is 10. Okay. So this is 10. Now, this is an extremely helpful piece of information because see, business maths total we know for business maths is 105. 20 plus 5 plus 5 plus 15, 35. 35 plus 25 is 60. 60 plus 10 is 60 plus 10 is 70. Now, y and 6y add up to 105 minus 70, which is 35. So y has to be 5. This has to be 5. This has to be 30. Now, if a plus 10 is 30, a itself is 20. A itself is 20. There are only 3 unknown regions left. This is so nice. Okay, 8th point. The number of students who passed only in commerce and accountancy, is this cell, is same as the number of students who passed in all 3 sections other than business maths. So these and this is 2/5 of the number of students who passed only in accountancy and economics. So accountancy and economics, if I take this as 5b, this will be 2b, and this will be 2b. These two regions are equal, and these 2 regions are 2/5 of this. Now look at the total for economics. 30 plus 5 plus 15 is 50. 50 plus 20 is 70. 70 plus 80, 70 plus 15 is 85. So these 2 regions here together should add up to 35. 7b is 35, so b should be 10. So this should be 25, and this should be 10. We know all numbers, and at this time it may seem like we have done everything, but remember, point number 1 is left. 20% of the kids have to be outside. That is left. So let's see how that works out. I know economics is 120. So let's add up the remaining numbers. 25, 50 plus 120, 170. 170 plus 50 is 220. Within these different sets, there are 220 people, and this is supposed to be 80%. If this is 80%, 20, the 20% will be 1/4 of this, or there are 55 kids outside. Within the four sets, there are 220 people, and 20% are outside. So 1/4 of that, 55 people are outside. Question 7. What is the total number of students in class 9? Which is a problem, which is why I was taking a pause at the beginning. It says 11 and this says 9. So I will edit it to 11 in the actual question. But what is the total number of students in class 11? 220 and 55. Total number of students is 275. How many students passed in accountancy? Okay, then I have to calculate this total for accountancy. 20 plus 10 plus 10, 40. 40 plus 25 is 65. 65 plus 30 is 95. 95 plus 40 is 135. Okay, 135 people passed in accountancy. Next is how many students passed in economics and at least one other section. Okay, so from economics, remove those people who passed only in economics. So from economics of total of 120, remove the 20, you're left with 100. That should be the answer. Next, how many students had to retake the test? Okay, retaking the test was when student failed in two or more sections. So if you have passed in 3 sections, you don't have to retake it. If you have passed in 4 sections, you don't have to retake it. How many people have passed in 3 or more sections? These are those people. I simply have to remove their count. So these 60 people don't have to retake the test, but out of the total 275 kids, apart from these 60, everybody has to retake the test. So answer here has to be 215, and that is the entirety of this set. Let's look at set 4. Vijay, the CEO of a company, wanted to take all the employees of his company for a conference. He chartered a plane for the occasion and delegated the task of assigning seats to his assistant Ravi. The plane had exactly 30 rows of seats, numbered 1 to 30. Okay. Rows were numbered 1 to 30 from front of the plane to the back, with 4 seats in each row. So total there are 120 seats. Ravi has to assign the seats to 120 employees from different departments, comprising 45 from marketing, 30 from finance, 25 from HR, and 20 from operations. Okay. He assigned the seats to employees starting from the first row to the last, from left to right in each row, ensuring that the employees of each department were assigned seats one after the other consecutively. Okay, what this means is if he starts off with finance, if the first person seated is finance, then all the remaining finance people will come in order only. All the finance folk will be exhausted first, then he will move on to some other department. This is what this last line means. He assigned the seats to the employees starting from first row to the last, from left to right in each row, ensuring that all the employees of each department were assigned seats one after the other consecutively. So if the first 30 seats were allotted to, let's say, finance, as in first seat was allotted to finance. So the first 30 seats are now allotted to finance. After that, let's say HR person comes, then the next 25 seats are allotted to HR. Then if next person is ops, all ops people will come. Basically what this line is telling us is the group of employees, these 4 departments, these employees within these departments are going to sit in consecutive seats one after the other. Whenever the first person of the department sits, everybody else has to sit in subsequent seats only. Okay, first question: if at least one employee from finance is sitting in row number 1, see, such a wonderful setup. If at least one employee from finance is sitting in row number 1, which means finance is right at the beginning. So finance is occupying seats 1 to 30. 1 to 30. At least one employee from HR is sitting in row number 30. See, if HR is sitting in row number 30, row number 30, how many people are there in HR? 25. 25. So last 25 seats I'm assigning. It will be 96 to 120 seat numbers. I'm simply going with seat numbers. Okay. And at least one employee from marketing is sitting in row number 24. Now see, row number 24 is as good as 69 to 72. 69 to 72 has marketing. Now this is fun. Look at finance. This will be row 1 to 7 in entirety. For finance, row 1 to 7 in entirety. And for the 8th row, 2 seats will be used up. For HR, 25 seats, no? So 6 by 4 I have to do. So 24th row mein 1 seat and then 25 to 30 in entirety. So finance is right at the beginning, HR is right at the end. This much we know. Prior to HR, some person has to be there. Prior to HR, some person has to be there. And we are told at least one employee from marketing is sitting in row number 24. Can I have marketing in the second spot? Let's say marketing was here. It has 45 people, no? If it has 45 people, how would it start? 45 people, 31 to 75 it would go to. 31 to 75. So it will start off with 2 people in the 8th row, gone. 2 people in the 8th row gone, 31, 32 gone. Now 32 to 75, there are 40. So 10 rows will be used up. 9 to 18 in entirety. 9 to 18, 10 rows in entirety. So 2 plus 40, so 3 more. 19th row will have 3 people. 19th row will have 3 people. But we were told in the question, marketing is sitting in row number 24. Is marketing sitting in row number 24? If marketing is the second set of second department to be placed in the plane, marketing will not be sitting in row number 24. So you cannot have marketing there. The second department cannot be marketing. There is only one department left. It has to be ops. How many people in ops? 20. So the seats that they will get will be 31 to 50. And how they will occupy it is 2 seats in the 8th row, gone. Then how many? 18 left. So 4 rows they will use up. 9 to 12 in entirety. Hopefully you're also picking up on the style in which I'm recording this. 13th row, 2 seats. After this, we will have marketing. Seat numbers that they will take up is 51 to 95, of course. Now, first they will take up the 2 remaining seats in the 13th row. Then 2 seats are gone. Out of 45, 2 seats are gone. 43 seats are left. So 10 rows will be taken up. 14 to 23 will be entirely used up. See, here I'm writing seat numbers. Here I'm writing rows that they are occupying. 2 seats in the 13th row. 10 rows will be entirely used up. So 2 plus 40. So 3 seats will be used up in the 24th row. This is the situation that is happening. So now the question asks me which of the following rows will be occupied by 4 employees from operations. Row 8, not really. 8 row is divided between finance and operations. Not great. 15th row is occupied entirely by marketing. Not great. 13th row is divided between operations and marketing. Not great. The 11th row is definitely entirely used up by operations. So answer should be option D. Hopefully this recording style, this structure of putting data down is something that makes sense to you. Okay, let us go to the second question. If there are exactly 2 employees from HR and 2 employees from operations sitting in the same row, and row number X has exactly 3 employees from HR, which of the following values can X assume? Okay, now see, HR has what exactly are they telling us? If HR and operations employees are sitting in the same row, it means they have to be in consecutive slots. They have to be in consecutive slots. So I can potentially have HR here and ops here, or I can have ops here and HR here. Yes. Okay. Now HR has how many seats? 25. Ops has how many seats? 20. So see, if HR is ending up, if there are 2 seats from HR and 2 seats from operations within the same row, it means if whatever person was here, if there was a person occupying seat, can I say after the HR people are seated, 4n plus 2 seats have been used up. I'm looking at the first case only right now. After the HR folks have been seated, 4n plus 2 seats have been used up. Look at finance, this is 4n plus 2. Look at marketing, this is 4n plus 1. Look at HR, this is 4n plus 1. And look at ops, this is 4n. If HR, after HR has been seated, 2 seats are left in that row. It means up until the point HR has been seated, 4n plus 2 seats have been used up. Now, if it started with HR, if HR was the first team to be seated, can it end up at 4n plus 2? No, HR is 4n plus 1 type of number. So they will occupy 6 complete rows, and then 1 extra seat. This doesn't work. So there has to be some group prior to HR. Some group prior to HR. Can I have some group prior to HR? Let's see. I can have marketing 45. I can have marketing 45. That is the only possibility. I can have marketing 45. Can I have finance and HR? Not really. It will make 4n plus 3. Can I have finance, marketing, and HR? No, it will make 4n itself. The only way it works is if marketing is the only one ahead of HR and ops is followed by finance. See how the seat numbers would be distributed here. 1 to 45, 46 to 70, 71 to 90, and 91 to 120. Rows wise, what would happen? I will take up this ops and HR case later. Ops and HR case later. Row wise, what would happen is this would be row 1 to 11 in entirety, and 12th row 1 seat. Here, 12th row 3 seats, then 22 people are left. So 5 rows will be used up. 13 to 17 in entirety. So 18th row 2 seats. Here it would be 18th row 2 seats. And here it would be 2 people are gone, 4 more rows needed. So 19 to 22 here. And 23rd row, there will be 2 seats taken. Here, 23rd row, 2 seats. And 24 to 30 will be taken up in entirety. This is how the distribution would take place. And now I have 2 employees, blah, blah, blah. Although the sad thing is I've already reached an answer. Okay. If there are exactly 2 employees from HR and 2 employees from operations sitting in the same row, and the row number X has exactly 3 employees from HR. Where do you have 3 employees from HR? 12 here. So which of the following values can X assume? 12 was given. So 12 will happen here. But let's say you started off, unluckily you started off with the other case. Ops first and HR later. Ops first and HR later. Ops first and HR later. If you're smart, you can see if you simply flip this arrangement around, nothing will go wrong. If you simply flip this arrangement around, fin first, ops then, HR then, and marketing right at the end, you can go that way. Even if you don't, again, remember, up until this point, we are supposed to reach 4n plus 2. Up until this point, we are supposed to reach 4n plus 2. Ops itself is 4n. So the number prior to that has to be 4n plus 2 itself, which is only possible with finance. And right at the end, we will necessarily have marketing. Now, this is 30 people. So 1 to 30 here, 31 to 50 here. Here it would be how much? 51 to 75. And here it would be how much? Here it would be how much? 76 to 120. Hopefully you also realize this is not in exam. I expect you to see this. 45 तक गया है तो 12th रो में 3 सीटें बची, HR खा जाएगा. या यहाँ पे 18 तक गया है, 72 gone, last 3 seats will be occupied by HR, so it is the 19th row being talked of in this case. I hope you are able to see that directly. Here, for the purposes of explanation, I'm going into great detail कि कौन से row में क्या बटेगा and everything. For finance, it will be first to the 7th row in entirety, and then 8th row 2 seats, 8th row 2 seats, then which 4 rows have to be taken care of? So 9 to 12 in entirety, and then 13th row 2 seats, 13th row 2 seats out of 25, दो जा चुके, 23 बचा, 23 बचा तो 5 चाहिए. So 14 to 18, and then 19th row 3 seats, and then finally 19th row 1 seat, and then 20 to 30 in entirety. This is how the distribution would take place. So our potential answers for question 16, our potential answers could be 19 also, could be 12 also. If you end up with 19, then because 19 is not present in the options, you can also get this clue from which of the following values can X assume, which means there are multiple possibilities exist. Why I did all this extra work is also on account of the fact, look at question 17. This question rewarded you for hard work that you did for the prior question. Question 17. If there are exactly 2 employees from HR and 2 employees from operations sitting in the same row and same row, and row number X has exactly 3 employees from HR, how many values can X take? Either 12 or 19. There are 2 values that X can take. So this is done. The third question is basically an offshoot of the second one. Okay, let me get back to our basic information patterns. What all did I know? Fin 30, Mark 45, HR 25, Ops 20. Okay, these are the only key important points, which I don't want to go back to the paragraph and see it again. Therefore, I write it again. Okay, next is, if exactly one employee from marketing is sitting in row number X, how many possibilities exist for X? Let's see. Can you see the two possibilities were already identified here? Row number 12 and row number 19 were already identified. So 12 and 19 are already done. When did we get 12? When marketing was the first company placed, and then when do we get 19? When marketing is the last company placed, or sorry, first department placed or last department placed. So 12 and 19, when marketing is first, and when, sorry, marketing is right at the beginning, marketing is right at the end. These two cases we have taken care of. Now see, can I have marketing in the second spot? I'm saying something prior to marketing, then something, and then something. Can I have something like this? Okay. Now marketing has 45 people. Now marketing has 45 people. The only way marketing will have one person here is if the people prior to marketing are is this is 4n plus 3 type of number. दिस इज 4n plus 3 टाइप ऑफ नंबर. यहां पे एक ही बचेगा कब? जब इससे पहले भी 4n plus 3 टाइप ऑफ नंबर हो. अगर 4n plus 3 टाइप का नंबर है, अगर if prior to marketing the number that was present was 4n plus 3 type, that person will take up certain number of full rows, and then 3 seats will be taken up, and then the last seat will be given to marketing. Unfortunately, sorry, this is not 4n plus 3 type of number, this is 4n plus 1 type of number. Can you see, this is 4n plus 1, this is 4n plus 1, this is 4n plus 2, and this is 4n, and this is 4n plus 2 kind of number. Marketing, I cannot have full rows of something and then at the last spot marketing आ गया और उसके बाद चल रहा है marketing वालों का काम. I cannot have that case क्योंकि marketing से पहले 4n plus 3 टाइप का कोई exist ही नहीं कर रहा है. So this would not work. This arrangement, this thought process would not work. Okay. But in what other case can I get it? Can you think? It would be so much fun. See, should happen is ऐसे ऐसे marketing के लोग जाए जा रहे और आखिरी में 3 लोग बच गए. सॉरी, नॉट 3 लोग, आखिरी में एक आदमी मार्केटिंग का रहा, उसके बाद एक नई डिपार्टमेंट के लोग बैठने लग गए. विच वुड मीन मार्केटिंग का आदमी जब हमने प्लेस किया है तो इससे पहले टोटल नंबर ऑफ एम्प्लॉइज शुड बी अ मल्टीपल ऑफ 4. मतलब मार्केटिंग से पहले, मार्केटिंग इटसेल्फ इज 4n plus 1, Some number plus marketing a number should be 4n plus 1. Can you see what that some number has to be? Has to be ops. If I place ops here, 20, together they would occupy what all? 65 seats. 65 seats. So 16 full rows will go, and in the 17th row, just one person for marketing would be there. In the 17th row, just one person for marketing would be there. 17th row, one person for marketing. Yo, hopefully you can see. अगर marketing से पहले ops को दिया, so there is a case where marketing can be placed in the second spot as well. Okay, let's check something else then. What we have placed marketing in the first spot, we have placed marketing in the second spot. This is the only case. Let's place marketing in the last spot. Let's place marketing in the third spot. Now here, what comes, finance or HR? I don't care. HR or finance, I don't care. Whoever comes, that is okay. Now, when marketing is in the third spot, again, if you can see symmetry here, you would be able to see from here to here, you could get this case by flipping it around, no? By simply turning it around. Can you also get that same storyline here? If marketing was followed by ops, what would happen? The storyline that we had, marketing followed by full rows, and then ops के rows चालू हो गए. ऐसा ऐसा हो सकता ना? Just one person of marketing here followed by this and this. So marketing followed by ops, and here fin or HR, HR or fin, कुछ भी चलेगा. In this case, what would happen is fin और HR मिलके कितनी seats खाते? Fin is 30, HR is 25, 55 seats. So in the 56th seat or in the 14th row, marketing will just have one seat. If you also pay attention, if symmetry is something that you can think of, यहाँ पे देखिएगा 12th or 19th. If you got to 12th, you got to 19th. If you were smart, you got to 17th here, you would have gotten to 14th row almost instantly. अगर 17 आ गया तब 14वें रो में ही होगा, because all we are doing is reversing the order. So how many possibilities are there? 14, 17. There are 4 possibilities. So option C. Okay, next question. Again, this question rewards you for the hard work you have done earlier. Look at this. An arrangement such as marketing, ops, fin, HR is called a potential sequence of arranging 4 departments. As we can see, there are 24 potential sequences. Basically, this is saying 4 factorial. कोई दिक्कत नहीं. We know that there exists a row where there is only one marketing employee. How many potential sequences is this possible? Now see, such a wonderful question. In how many potential sequences is this possible? Let's see. First case was when marketing was right at the top, then the 3 departments after it in any order. So this will happen in 3 factorial ways. The second case was the 3 departments in any order previously, followed by marketing right at the end. In this case, you've got 2 cases separately. Finance and HR can flip places. In this case, finance and HR can flip themselves in 2 ways. So how many different sequences are possible? 2 plus 6 plus 6 plus 2, altogether 16. So this is the answer. Again, prior question is helping us solve the subsequent one. Okay. Last one. Let me just get rid of this because this is a new idea being tested in the last one. If an employee from operations is sitting in the same row as the employee from finance, which means operations and finance are next to each other. Next to each other as in adjacent, as in these departments have been arranged adjacently. Okay. And another employee from operations is sitting in the row immediately ahead of the row in which an employee from marketing is sitting. Okay. So now I know the ops people are ahead of marketing. I also know ops and fin are adjacent. So fin has to be ahead of ops. The order for these 3 is uniquely known. In which row number will there be definitely more than 2 employees from finance sitting? HR's location we don't know. So there are 2 possibilities. HR could be right here, or fin, ops, marketing, and HR, We can have both these possibilities. HR के देखते seat is 1 to 25, fin का seats is 26 to 55, ops का seat is 56 to 75, marketing का seats is 76 to 120. In this case, seats are 1 to 30, then ops is 31 to 50, marketing is 51 is 95, and HR is 96 to 120. Okay, so this row wise I'm writing. You can go with finance directly. What all is happening in the seventh row? They will have 3 seats. Seventh row, 3 seats, 26 to 28, and then 28 to 52, 7 to 13, or 3 people gone, 22 people left, 5 rows. So 8 to 12 gone entirely. And then finally in the 13th row, 13 कैसे होगा? 7th row में इतना गया. अच्छा हाँ, 5 rows नहीं होगा यार, 6 rows होगा. 30 people in total in finance, no? So 3 people gone, 27 left. 4 से divide किया तो 6 आया. So 8 to 13 will go. In the 14th row, another 3 people will sit. 3, 3, 8 to 13. This is done. Finance के लिए seats would be these. Here the seats would be row 1 to 7 in entirety. And then 8th row will have 2 people. This is what we know for finance. Direct numbers से पता चल सकता है. Now they are asking me, in which row number will there definitely be more than 2 employees from finance? Pay attention, more than 2 employees. In दोनों के अंदर, can you see? In row number 7, you have 3 employees here, you have 4 employees here. Row number 8, overlapping hai, but you only have 2 employees here, you have 4 employees here. We needed more than 2 employees. So the only case that is possible is in row number 7, and that is the entirety of this set. This is a fun set on account of not having a lot of processing, but you carefully understanding the language and then placing things. Additionally, those of us who are familiar with puzzles will be rewarded on account of being able to see the flips happening within the question. That is the end of this test. Let's look at this set. 1 minute. The population of each of 8 cities, Antarpur, Blazepur, Chastipur, Dustipur, Lakden, Hyderabad, Mathpur, and Kanpur, was divided into exactly 5 groups: infants, kids, teenagers, adults, and elderlies. The following graph provides the number in million of infants, kids, and teenagers. So out of the 5 groupings that were talked of, infant, kids, and teenagers, adults, and elderlies, only 3 numbers are available to us directly. Only 3 numbers are available for each of these 8 cities. It is also known that the total number of kids and adults is same across the 8 cities. Okay. Kids का number मेरे को दिया है और बताया है kids plus adults are identical everywhere. Please, kids plus adults is identical everywhere. Further, the total number of teenagers, adults, and elderlies is also the same across all 8 cities. So teenagers, adults, which is figured out from here, and elderlies also add up to the same number. Okay. So clearly, this graph is of no relevance to us. We have to create a table. The table will look something like this: A, B, C, D, E, F, G, H. नहीं, A, B, C, D, E, F, G, H तो है ही नहीं. D के बाद बदल जाती दुनिया. D, L, H, M, and K. These are the 8 things. Then we have infants and kids and teenagers and adults and the elderlies. Now, for the first 3 columns, we can fill the numbers from the table directly. Say we were doing it for Antarpur. You would have infants as 10, the blue mark, then kids as 20, and then teenagers as 40. This is known to us. We can populate the entire table for these three values quickly enough. But I'm getting into how the recording should take place or how I would have done recording. Now, I'm coming to this part. It is also known that the total number of kids and adults is same across the 8 cities. So I'm saying let kids plus adults be equal to x, some value of x. So if kids plus adults is equal to x, can I say adults in Antarpur will be x minus 40? The number for adults in Antarpur will necessarily be x minus 40. Sorry, not x minus 40, x minus 20, because kids plus adults on other. Kids plus adults I'm taking as x. And now next thing is we are told teenagers plus adults plus elderlies are also the same across the 8 cities. So teenagers plus adults plus elderly is equal to y. Let's say this is equal to y. So now y, if this is y, I get y minus 40 minus x plus 20. Or can I say elderly is equal to this? For the first city only, I'll have y minus x minus 20. These notations can be done and we can fill up this entire table. We can fill up this entire table using these data points, using these frameworks. I've already created a table on the next page because that will be nicer for me to record. Recording these numbers is not a challenge. Going back to our setup, kids plus adults is equal to x. So if kids plus adults is equal to x, adult here will be x minus 20, x minus 10, x minus 20, x minus 10, x minus 30, x minus 10, x minus 20, and x minus 30. Why I have written it this way? The purpose is, now I also know one wonderful thing. X has to be greater than equal to 30. Because the count of adult can at worst be 0. So I have identified one condition. X has to be greater than equal to 30. X has to be greater than equal to 30. Now utilizing my other setup of elderlies. See, elderlies plus teenagers plus adults is equal to y, or elderlies is equal to y minus teenagers minus adults. I will get, see, every adult has a plus x. So every elderly will have a minus x. So y minus x, and 40 minus 20. 40 minus 20 gives me 20. So subtract the 20 from here. Then y minus x minus 40. Then here y minus x. Then here y minus x minus 50. Then y minus x, y minus x, ठीक नहीं कर रहा, हाँ ठीक कर रहा, y minus x again, then y minus x minus 10, then y minus x minus 20, and finally y minus x plus 10. This last thing will be plus 10. Essentially what I've done is I've taken these three things, I've ensured they are equal to y. These three things are always equal to y, teenager, adult, and elderly. They're always equal to the same variable. What this enables me to get is the total for each city will now be y plus 30, y plus 30. Here it will be y plus 30, y plus 60, and y plus 20, and y plus 60, and y plus 20, and y plus 50, and y plus 70. I have listed out the totals everywhere. The additional thing that we can see is, see, from
each of these expressions, this is the most interesting expression. For Dustipur, the expression is most interesting because now y minus x has to be greater than equal to 50. This condition is also in play. And y has to be greater than equal to x plus 50. Because we know x is greater than equal to 30, y has to be greater than equal to 80. These are three disparate conditions that we have obtained. These are three disparate conditions that we have obtained, and we have to ensure that all these three conditions get fulfilled, whatever question, whatever variation we are solving. Okay, first question. Which city has the highest population? The highest population is clearly with Kanpur. So option B is the answer. Next, if the number of adults in Antarpur, x minus 20 is 2/3 the number of adults in Dustipur, y minus x minus 50. Sorry. 1 minute. Number of adults in Antarpur is x minus 20 is 2/3 the number of adults in Dustipur, x minus 10. What is the total number of adults in all the 8 cities combined? This is wonderful. This gives me a precise value of x. I get 3x minus 60 is equal to 2x minus 20, or x is equal to 40. And this is wonderful. I can get to summation now. I will have 8x minus something. What that something is, I simply have to add up these numbers: 10, 20, 30, 10, 20, 30, 60, 10, 20, 30, 60, plus 50. So 8x minus 150, because x was 40, 320 minus 150. The answer here will be 170. I have limited space and therefore I will erase this off. Because that is not required for the next question. The first two questions were fairly doable. It wasn't too much to work around. The next question, however, is a whole another gravy. If the number of adults in Herebad is twice the number of elderlies in Chastipur, number of adults in Herebad is twice the number of elderlies in Chastipur is equal to 2y minus x Chastipur, then which of the following can best be said about the ratio of population of Mathpur to Kanpur? For Mathpur to Kanpur, we need y plus 50 and y plus 70. A brief glance of the options will tell you the upper side is always 1. The upper limit is always 1. So I'm not really checking for upper side. I'm looking for the smallest portion or the smallest side. Now here I get x minus 10 is equal to 2y minus 2x. The next case, or how I can turn it around, is 3x minus 2y is equal to 10. 3x minus 2y is equal to 10. I can come up with insane number of solution sets for this. I can come up with thousands of different solution sets for this. But I want to come up with the solution set where y is as low as possible, because I'm looking for the lowest ratio number. Okay, so let's see how can I get that. First case I see is 3 into 10 minus 2 into 10. This is going to be the first case. This is definitely going to be the first case. 3 into 10 minus 2 into 10 gives me 10 difference. This is absolutely fine. But I also had these three constraints in play. So the next case that I can create, this will go up by 2, this will go up by 3. This way it can go. But how far do I have to go into the future, or how far do I have to go forward? First thing I'm ensuring is this. But you can ensure anything. Once that is ensured, you have to check the next thing, then you have to check the next thing. Right now I'm ensuring x is greater than equal to 30. So from 10 to 30, if I go in steps of 2, from 10 to 40, I will go here in steps of 3.
From 10 to 30, if I go in steps of 2, 10 to 40, I will go in steps of 3. Is 30 and 40 acceptable? See, X, this condition is met. Let me call this condition 1. Let me call this condition 2. Let me call this condition 3. At this stage, condition 1 is met, but condition 2 and 3 are not met. So I have to ensure condition, whichever condition you want to go forward for. You can see in every step, the gap increases by 1. Previously, the gap between them, X and Y was 1. Then the gap was 0. Then the gap was 1. The next case created will have gap as 2. Next case created will have gap as 3. So on and so forth. We keep on going. So right now the gap is 10. Right now the gap is 10. I want that gap to increase to 50. I want that gap to increase to 50. So I need 40 more steps. If I need 40 more steps, 40 into 2 more, 40 into 2 more, this will get to 110. And 40 into 3 more, this will get to 160. 3 into 110 minus 2 into 160 will give me a difference of 10. Yes. At this spot, condition 1 is met, condition 3 is met, and condition 2 is met. All these 3 conditions are definitely met here. All these 3 conditions are definitely met. And in fact, this is the first spot where all 3 conditions are met. This is the first time the difference between Y and X will be greater than or equal to 50. So once this is identified, the lowest possible value that Y can take is 160, which leads us to the lowest possible value of this fraction will be 160 plus 50 by 160 plus 70, which is equal to 210 by 230. Now 210 by 230, let me divide 210 divide by this 2100. So 9 times 207, then 30. So 9123. Among the options, clearly it has to be option D. Clearly it has to be option D. The fact that these 3 conditions had to be met at the time of creating cases here is what makes or breaks the case counting here. Okay. The next storyline now. I have erased too much. I should not have erased these things. 1 minute. I think this should be enough. Here, let me erase these. Now the 4th question in the set. If the number of adults in Hyderabad, X minus 10, is same as the number of elderlies in Kanpur, is equal to Y minus X plus 10. Number of adults in Hyderabad is same as the number of elderlies in Kanpur, and the number of Anantapur is twice the number of elderlies in Blazipur. This is one equation. Number of adults in Anantapur, X minus 20, is twice the number of elderlies in Blazipur. Is 2 times of Y minus X minus 40. Then what is the population in million of Lagden? The wonderful thing is I have 2 equations, I have 2 variables, they can happily be solved. So first thing I'll get is 2x minus y is equal to 20 from here. From here I'll get x minus 20 is equal to 2y minus 2x minus 80. I would want to take it to the other side. This becomes 60 and I have 2y minus 3x. So I have 60 is equal to 2y minus 3x. So let me multiply this equation by 2. I'll get plus 4x minus 2y is equal to 40. So if I add both these equations up, I get 100 is equal to x. And if 100 is equal to x is equal to 100, then y will be equal to 180. If y is equal to 180, population of Lagden I need, y 180, y plus 60 is 240. So answer will be option C. Last question now. Let me get rid of all these workings. Next, if the number of adults is the same as the number of elderlies in at least 2 cities, then which of the following
can best be said about the ratio of populations of Chastipur to Dustipur? Okay. Number of adults is same as the number of elderlies in two cities. What comes to our rescue here is look at the number of adults. There are only 3 counts of number of adults. The first count is this x minus 20, x minus 20, and x minus 20. The second count is this x minus 10, x minus 10, and x minus 10. And the third count is this x minus 30 and x minus 30. How I'm going about checking or identifying those two cities, identifying those two cities is this way. Look at Anantapur and Blazipur. I will only check Anantapur, x minus 20 with x minus 10s and x minus 30s. See, here the population has increased by 10 for adults from Anantapur to Blazipur. The working that I'm doing is Anantapur and Blazipur comparison. Adults have increased by 10 and elderlies have dropped by 20. So Anantapur and Blazipur can't be that pair which has the same number of adults and elderlies. How about Anantapur and Dustipur? Adults have increased by 10. About Anantapur and Dustipur? Adults have increased by 10, but elderlies have dropped by 30. This is also not a fair grouping. How about Anantapur and Hyderabad? Anantapur and Hyderabad. Adults have increased by 10. And elderlies have also increased, by 10. So this pair, as of now, this pair seems promising. This seems promising that this would be that pair, where the adults and elderlies are identical. But then this is not the end of the checking. We have checked x minus 20 with x minus 10s now. The next thing to check is x minus 10s with x minus 30s, x minus 10s with x minus 30s. So let's see x minus 10 with here. I'm checking Blazipur and Lakden. Blazipur and Lakden. Adults have dropped by 20, but elderlies have risen by 40. So can't work. I'm checking Blazipur with Kanpur. Adults have dropped by 20. Elderlies have risen by 50. So this can't work. And that is useless. I'm not, in case somebody is having this idea, I'm not checking x minus 20 with x minus 20 because clearly if both these numbers are identical, that pair will be identified. But both these numbers cannot be identical because if both these numbers are identical, can you see if this number is equal to this number, essentially if Mathpur and elderly's number is identical, that cannot be because that would mean elderly's is equal to entirely 0. That is not possible. We are only looking for two cities in which number of adults and elderlies are identical. Okay, so this is done. I have looked at the x minus 20 with x minus 10 grouping. I haven't checked x minus 20 and x minus 30. Let me check that. So next case would be Anantapur to Lakden. Adults have gone down by 10. Elderlies have gone up by 20. No. Anantapur and Kanpur. Adults have gone down by 10. Elderlies have gone up by 30. No. Which means the only case that is being referenced here, if the number of adults is same as the number of elderlies in at least two cities, those two cities have to be A and H. So what is being told to us is x minus 20 is equal to y minus x minus 20.
Okay, x minus 20 is equal to, or minus 20 gone. 2x is equal to y. If 2x is equal to y, then can I replace it here? I will get, in condition 2, I will get 2x minus x has to be greater than equal to 50. Or x has to be greater than equal to 50. So if x has to be greater than equal to 50, and y therefore has to be greater than equal to 100, y has to now be greater than equal to 100. What do I need? Finally, I need the ratio of Chastipur to Dustipur. Now see, Chastipur to Dustipur, their basic ratio is y plus 60 by y plus 20. The more we keep on increasing this ratio, the numerator is larger than the denominator. The more we increase this ratio, the closer it will get to 1. The more we increase this ratio, the closer it will get to 1. But the minimum value of y when I take, that will give me the largest value of this fraction. Minimum value of y that can be obtained is 100. So the largest possible fraction or the largest possible ratio will be 100 plus 60 and 100 plus 20, which is equal to 4 by 3, which is equal to 1.333. So this is the case and this is the case. But between the two of them, hopefully you can see this ratio will never go below 1. This ratio can never go under 1. And therefore, this option or this number makes option B unacceptable. The correct answer has to be option A, and that is the entirety of this set. What is critical is how you take variables in this set, and then along with that, you have to ensure that these conditions are met at the time of your case filling. Otherwise, the cases that you're counting or the extreme situations that you're checking, they may not necessarily meet all conditions. Some cell somewhere may end up becoming negative, which is of course unacceptable. That will be all. Let's look at this set. In a college, there were a certain number of students and each took one or more among 5 subjects: OM, OB, Econ, FRA, and MSc. However, any student who took MSc also took FRA, while any student who took OM also took OB. This is the identification that this is a set theory question. And because this is a set theory question with 5 sets, the first fear has to be that 5 sets का Venn diagram बनाना तो मैं आता नहीं है. But 5 sets का Venn diagram बनाना नहीं है क्योंकि we have these additional conditions. Anyone who took MSc also took FRA, while any student who took OM also took OB. So what I'm doing is I'm creating a 4-set Venn diagram, and large 4-set Venn diagram, not a small one, fairly large one, because it is always better and nicer to make a large Venn diagram. And then I am creating this. What I mean by this representation is any student who took MSc also took FRA. So I'm saying let this be MSc, let this be FRA. MSc is entirely present within FRA. There is no chance that anybody who has taken MSc is not taken FRA. And the other subjects were OM, OB, and Econ. Okay. Now, any student who took OM also took OB. So OM without OB cannot exist. So this is gone, 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 this is gone. We have this available. Regions are getting cancelled out. We are extremely happy. Next, we have additional data points to take care of. The number of students who took exactly 3 subjects was the same as the number of students. Oh, sorry. It is also known that each student took at least 3 of the 5 subjects. Everybody has to take 3 of the 5 subjects. Now, within this Venn diagram, what is going to be challenging is identifying what are 3 set Venn diagrams or 3 sets ke regions, exactly 3 set regions or exactly 4 set regions and exactly 5 set regions. So what I'm doing is I'm going ahead and marking them. Exactly 3 set regions, exactly 4 set regions and exactly 5 set regions. I will put this as 3, put this as F and put this as star, pentagonal star. So first, all regions that have exactly 2 sets will go away. Exactly 2 or exactly 1, those regions will go away. So how many am I left with? 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the only regions that are. Now within these, this represents people who are part of exactly 3 sets. This represents people who are part of exactly 3 sets. This represents people who are part of exactly 3 sets. This represents people who are part of exactly 3 sets. And anything else? This is 4 sets, this is 5 sets. So this is all 5 sets. Okay, this represents people who are part of exactly 3 sets. My T and F can be confusing, so I will change this F to circles. This is region overlap. This is overlap of exactly 4 sets. This is overlap of exactly 4 sets, and this is overlap of exactly 4 sets. So there are 5 regions that have overlap of exactly 3 sets. There are 3 regions that have overlap of exactly 4 sets, and there is 1 region that has overlap of all 5 sets. Okay. Next is the number of students who took exactly 3 subjects was the same as the number of students who took both from FRA and Econ. Now, FRA and Econ, we don't have anything defined in these regions. Remember, these are markers. These are not variables. T and star and these things are not variables. These are simply markers. So, for the time being, we'll let it cook. Statement 1, we are not doing anything about it right now. We don't have anything available. The next is the ratio of number of students who took OM and that who took Econ is 9:10. So if I have 9x students here, I have 10x students here. OM to Econ is 9x and 10x. Okay, I will worry about it later. The number of students who took exactly 4 subjects is 80, and those who took exactly 5 subjects is 100. Exactly 5, I know the precise ilaka, so this has to be 100. Now these 3 regions add up to 80. So what I'm doing is, I am writing A, I am writing B, and therefore this will turn to 80 minus A minus B. 80 minus A minus B. These 3 regions, I have defined it this way. Okay. Next is among the students who took OM, exactly 130 students also took MSc. Among the students who took OM, exactly 130 students also took MSc. Now, OM and MSc have an overlap of what regions? They have an overlap of this one here. Let me mark those regions that are overlapping between OM and MSc. This one here and this one here. These are the only 2 regions that can have some sort of population. And we are told among the students who took OM, exactly 130 students also took MSc. That is another way of saying, oh, this B is not really B. This is 30. And once I have B available as 30, my intent is to get rid of variables as quickly as possible. So this region here is no longer 50 minus A minus B. Sorry, this is no longer 80 minus A minus B. This is 50 minus A. This is 50 minus A. Okay. Now, and among the students who took MSc, exactly 125 students took Econ. Students who took MSc and Econ will be denoted by these green regions. So these three regions are supposed to add up to give me 125. So this here should be 25, sorry, not 25, A minus 25. See, the summation of these three regions will happily be 125. Wonderful. Next thing informed to us is not more than 155 students took MAC. Now, this is the critical part. If you're able to get it quickly, then things will flow smoothly. Not more than 155 students took MAC. I already have 130 students for MAC here. I already have 130 students for MAC here. And for these two regions only. Remember, the green regions add up to 125. This region was already 30, which means here there is nobody present. This is an empty region. Not more than 155. I already have 155 people available in MSc. So 30, 100, 50 minus A and A minus 25. 155 people are already mentioned in MSc. We can't go anymore. And among the students who took FRA, exactly 230 students also took OB. Among the students who took FRA, exactly 230 students also took OB. Again, I will try my level best. I'm removing these red and green dots because I will need that color again. FRA and OB overlap regions. FRA and OB overlap regions are going to be this, 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 and this. These are the regions. Sorry, yes, these are the regions that are common to FRA and OB. That are common to FRA and OB. Okay. Now see, if I these four regions 30, 100, 150, minus A and plus A. Can I say 180 people have already been accounted for? 30, 100, 50, 180, minus A and plus A. In these four regions, 180 people have been accounted for. So, if I introduce a new variable B here, this here will be 50 minus B. This is B and this is 50 minus B. This is B and this is 50 minus B. Okay. Anything more left? No, nothing more is left. The only region that we have not defined so far, is this region here. I'm calling it N. I've defined this, I have defined this, I have defined this. The first 2 points are left. Let me check the first 2 points. The first point says the number of students who took exactly 3 subjects. Exactly 3 subject regions are B plus 50 minus B plus N plus A minus 25. These are the 4 regions that are for exactly 3 subjects. Was same as the number of students who took both FRA and Econ. FRA and Econ overlap are these 5 regions. And these 5 regions, these 3 add up to 125. 125 plus A plus B. Let me work my magic. This A is gone, this A is gone, this B is gone, this B is gone. 25 left. So N is equal to 100 plus B. This B will go here, become plus. 25 will go here, become this. So this will turn to 100 plus B. Basically, I am getting rid of variable N from my storyline now. I no longer have N to worry about. Now, in my entire storyline, I've used every point. I've pretty much used every point except the second one. Let me use that second one. First, let me identify what is OM, what is the summation for OM. 130 plus A plus 150. This is OM. And Econ is how much? 125 plus A plus 2B plus 100, and we are told they are in the ratio 9/10. They are in the ratio 9/10, OM and Econ. Now, if you have kept a keen eye, you will also see there is one additional condition. A has to necessarily lie between 50 and 25. A cannot be more than 50 because then this region will turn negative, and A cannot be less than 25 because then this region will turn negative. So A has to be in that range. Working our magic here, we get 2800 plus 10A is equal to 2025 plus 9A plus 18B, or equation wise what we have is 18B minus A is equal to 775. 775. And now we have to identify solution sets. Okay. 775 upon division by 18 leaves what remainder? 2 से रिमाइंडर 1 है, 9 से रिमाइंडर क्या है? 7 7 14 14 5 19 19 से, सो 9 से रिमाइंडर 1 है, 2 से रिमाइंडर 1 है, तो 18 से रिमाइंडर 1 ही है. This is leaving a remainder of 1 with 18. So what I need is A has to be 17, so that it goes here. It will turn to 792. 792 divided by 18 will be how much? 720 divided by 18 is 40, and 72, so 44. I get this as my first solution set, B being 44 and A being 17. B being 44 and A being 17. But then this is not acceptable. This is not acceptable because A has to be within this range. Next case then, B being 43 and A being 35. This is an acceptable case. B being 43 and A being 35. It has increased by 18. It has gone down by 1. The next case being this being 53 and this being 42. Again, this is unacceptable. A has to be within this range, which means A can only take one value of 35. B can only take one value of 43. So this region here is 143. This region here is 43. This region here is 7. This region here is 35. This region here is 15. This region here is 10. I'll also mark all the other colors in a different number. And we have pretty much every region uniquely identified, the total numbers known. We can get to individual questions now. First thing is, what is the total number of students in college? Wait, I will have to do lots of work before I move. First thing is, 35 here. So I had 280 plus A here, no? So 315 here. 315 here, which takes care of these 5 numbers, I'm guessing. 150, yes. And then I have have I made a mistake somewhere? Wait, I had 18B minus A is equal to 775. The first case identified was A being 17 and B being 43. Okay. No, not this, 44. Now that I have to increase, if A is increasing, B also has to increase. So if this turns to 35, this will turn to 45. Yes, I have made a mistake. So this should be, I have also erased regions, so, but let me remember. This should be 145. So this should be 5. This should be 45. A remains 35, no problem. This remains 315, that is okay. This gives me 60 plus 10, 70. 315 plus 70. Okay, this should be 385, which is fine. It should be 385. I made a mistake earlier in 18B minus 775. When A is increasing, B should also be increasing. I took it to 43, which is flawed. Anyway, what best can be said about the number of students who took Econ but not OB? Students who took Econ but not OB. Econ but not OB is only these people. Only these people who took FRA, MSc, and Econ. These are the only people who took Econ but not OB. So answer should be exactly 10. Which of the following provides the comprehensive list of subjects that would have been taken by maximum number of students? Okay. I know OM is 315, and if this is 9x, Econ has to be 350. This is nice. Or I know total is 385. No, everything is contained within OB apart from this 10. So this will be 375. And in FRA, everything is contained apart from this 145. So this will be 240. So OM and OB, no, OM is lower. FRA is 240, Econ is 350, OB is 375. So OB. Next, what best can be said about the total number of students who did not take only Econ? See, if you have not taken only Econ, you have taken 4 subjects. And if you have not taken only Econ, the 4 subjects that you would have taken will be FRA, MAC, OM, and OB. And there are 30 of those people, 30 here. Next, what is the difference between the number of students who took exactly 3 subjects and the number of students who took MSc? Exactly 3 is the T regions. So 45 plus 5 is 50. 50 plus 10 is 60. 60 plus 145 is 205. And people who took MAC is 125 plus 30. So 155. The difference between them is 50. And that is the entirety of this set. The things that had to be taken care of. One, even if it is a 5-set Venn diagram, it's not really a 5-set Venn diagram. It's a 4-set Venn diagram that has been modified. Then you had to define regions very carefully. What is a 3-setter region? What is a 4-setter region? What is a 5-setter region? Then positive information had to be captured. As soon as you come up with new information or new interpretation, you keep on removing the older count of variables. Once you have gotten rid of enough number of variables, you come to your final conclusion, and then don't make a silly error after doing all the work, because then it will become bad. That is all for this set. In the year 2018, 3 universities, IIS, IIB, and IIK, together conducted a research aptitude test, RAT. The following information is known to all candidates who appeared for RAT. Okay. Pay attention. Usually the instructions for a question are about the following information is known for about those who appeared for RAT, but this is known to all candidates. So candidates have a role to play in this question. Starts from here. The scores of RAT were valid for a period of 5 years, from 2018 to 2022. And during these years, the test would be conducted only once, which was at the beginning of 2018. Okay. Which is another way of saying, in 2018, RAT was conducted and these scores are valid for 5 years. Okay. The candidate who appeared for RAT can apply to their preferred university in any year from 2018 to 2022. However, each candidate can apply only once, irrespective of the university that he applies to. So, I'm doing 2018, 2019, 2020, 2021, and 2022. In these 5 years, people are applying to different universities, those universities being IIB, IIK, and IIS. This condition is important. Each candidate can apply only once, irrespective of the university that he applies to. So if you apply to that university and you don't make it, you don't make it at all. It is not like you get to apply in the next year based on that score. Okay. Each university has a total number of vacant seats to fill over the above mentioned 5-year period provided in table 1.
from among the candidates who appeared for RAT. So 6 people need to go to IIB, 6 people need to go to IIK, and 3 people need to go to IIS. Okay. Among the candidates who apply to any university in any year, the university will select the candidates who achieve the highest marks in RAT and will select the maximum possible number of candidates subject to availability of vacant seats in that year. Which is another way of saying IIB will select everyone who has applied to IIB, or among the people who have applied to IIB will select people based on the highest RAT score getters and if there are vacant seats available. 2 factors they have to take care of. One, if there are vacant seats available, and then among the applicants, those who have a higher score will get selected. Okay. Exactly 15 candidates A through O appeared for RAT in 2018. Further, when results were declared, an administrative error led to the scores of all 15 candidates provided in table 2 being shared with each candidate. Okay, so now the candidates know all these rules and they also know the RAT score. This column is known to all the candidates. Also, each of the candidates had a first preference and the second preference regarding the university that he wanted to join, which is provided in table 2. The preferences of each candidate were not known to the other candidates. So the things that they know are number of seats available and the RAT score of every other candidate and their own RAT score, of course. Every year, each candidate will first logically infer as much information as possible based on the facts available to him. This is a rephrasing of a very simple instruction, which is to say, everyone is rational, everyone is logical. Nobody is blindly playing this game. People are making logical conclusions and then deciding their future course of action. Apply to any university if and only if that university is either his first or second preference, and he is sure that he will be accepted into that university in that year. You will only apply if you're sure you will get into that university that year, whether it is your first preference or your second preference. But unless you are guaranteed a seat in that university, you are not going to apply. Okay. Apply to the university which is his second preference only if he's sure that there are no vacancies in the university which is his first preference. As soon as all the seats in your preferred university, in your first preference, all the seats are filled up there, then you will no longer apply there. You will apply to your second preference. But to the extent possible, you are going to try to get into your first preference. Okay. Each candidate knows that every candidate would follow the above process for applying to any university. Basically, everybody is playing logically. Nobody is randomly playing in air. Everybody is playing logically. Further, at the end of each year, every candidate knew the exact university each candidate had joined during the year. So if you end up joining someplace, other people will know, and thereby they will also know how many vacant seats are left in that particular university. Okay, let's go through our list of candidates. E is the highest scoring candidate. He has the world at his fingertips. He can join any college, any year, whenever he chooses to. So E will apply to IIB and make it here in the first year itself. He gets his first preference. He joins in first year and he gets his first preference year and preference. I'm writing it simultaneously. F, he wants to join IIB and he knows that there are 6 seats in IIB. Even if E wants to join IIB, there would still be seat available for F. So he will join IIB in 2018 itself. First year, he gets his first preference. Okay. Next, IIS. B has a preference for IIS. Now, IIS has 3 seats. Even if it is the worst case that E and F both want to join IIS, B is guaranteed that he will get his seat in IIS. So he will apply and get IIS in 2018. He will get his first preference in the first year. Now look at L. L. His problem is different. He will not be certain that he gets admission into IIS. He will not be certain because there are 3 people ahead of him. If all three of them apply to IIS, his preferred destination of IIS will not materialize. So he will hold off on applying this year. He will not apply this year. L will not apply this year. Okay. Let's look at O. O has a first preference of IIB. First preference of IIB. Now, IIB is supposed to have 6 seats. Even if all the people ahead of O, LBFE, if all of them applied to IIB, still O is guaranteed to get a seat in his preferred institution. So O applies in 2018 itself in the first year and he gets his seat. First preference he gets. Now A is again IIS, very much like L. He's not going to be certain and he will hold off. He's not going to be certain to get a seat in IIS because there are 5 people ahead of him. And if 3 out of those 5 end up applying to IIS, he will not get to his preferred destination. So he holds off. A holds off. Then let's look at D. D has 6 people ahead of him. A, O, L, B, F, E. Because he has A, O, L, B, F, E ahead of him, because he has A, L, O, B, F, E ahead of him, D cannot be certain that he gets IIK. If everyone ahead of D had given IIK as his preference, then D cannot get into IIK. So he will also hold off. And everyone after D will also hold off because only people up till the 6th position, can be certain of getting admission in their desired college. D has 6 people ahead of him and there were only 6 seats in IIK. So D cannot be certain. I has 7 people ahead of him and there were only 3 seats in IIS. So I cannot be certain. M has 8 people ahead of him and there are only 6 seats in IIK. So he cannot be certain. This much is known. Now, at the end of the year, 2018 is done. These many people have joined. Right now, nobody has joined IIK. 3 people have joined IIB and 1 person has joined IIS. At the end of the year, every candidate knew the exact university each candidate had joined during the year. So, they should also, not only will they know which colleges they have joined, they will also be able to infer something extra. See, everyone would see that L, despite being the 4th highest scorer, has not joined a college. If L has not joined a college, if L had his first preference as IIB, he would have joined. If L had his first preference as IIK, he would have joined. If L has not joined, this is a guaranteed outcome that L's first preference is IIS. Similarly, then they look at A. A has only 5 people ahead of him. If his first preference was IIB, he would have definitely joined. If his first preference had been IIK, he would have definitely joined. The fact that he has not joined in the first year tells people that his first preference is definitely IIS, which also tells people that these two people are the 2 top rankers left for the second year. And they are getting their first preference. They are getting to IIS. L is coming here, A is coming here, L is coming here, A is coming here, which also should now tell everyone below them would be able to infer that IIS is no longer available second year onwards because L and A have IIS as a preference and they are the top 2 rankers left. So this option is gone, 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 and this option is gone. IIS is no longer available to people second year onwards. Apart from LNA, nobody would be able to join IIS because LNA are definitely joining IIS. This is done. Let us move on to the next person in the list, D. D sees that nobody has joined IIK so far, and L and A want to go to IIS only. So his seat in IIK is guaranteed. So D will come here. Now look at I. Look at I. I's first preference IIS is not available because L and A will take up the 2 remaining seats. His second preference of IIB. Is he guaranteed to get a seat in IIB? Yes. Worst case, see, L and A are definitely going to IIS. Worst case is if D also applies to IIB, still there would be 2 seats available. Still there would be 2 seats available. So I fills up IIB, He applies in second year, gets his first preference. And I applies in second year and gets his second preference. I comes to IIB. Then let's look at M. M's first preference is IIK. Is he guaranteed to get admission in IIK? Yes, there were 6 seats available. L and A, who are above him, are not joining IIK. Even if D and I join IIK, M will get his preferred location of IIK. So M is joining this year. He's joining in second year, and it is his first preference. Okay. Next is G. He's not joining IIS, but IIK, can he join? 1, 2, 3. 3 people ahead of him. 3 people ahead of him. And he wants to join IIK. Even if all 3 people ahead of him, end up joining IIK, he's still guaranteed to get a seat in IIK. So G will also join in this year. He will join in second year. He will get his second preference. Okay. Let's look at J. J is going to be in a quandary. Why J is going to be in a quandary is IIB has, at the beginning of 2019, IIB had only 3 seats available. Among those 3 seats, he doesn't know if D, I, M, or G. If 3 of them end up choosing IIB, he will not get IIB then. And therefore, he holds off on applying in this year. J holds off on applying in this year. Next year, next person, N, similar to J, he holds off on applying. Similarly, K holds off on applying. Similarly, C holds off on applying. And similarly, and H has 1, 2, 3, 4, 5, 6, 7, 8 people ahead of him. So H also holds off on applying. At the end of the second year, these many people have eventually joined their desired colleges. At the end of the second year, these many people have joined their desired colleges, desired universities, and they are guaranteed to get a seat wherever they have applied. Now, next year onwards. Prior to next year onwards. Right now, see, people see that J, he can either have a preference of IIB or IIK. If he had a preference of IIK, if J had a preference of IIK, would he apply in 2019 itself? Of course. Worst case scenario was D, I, M, G all had joined K. Still, J would have had a seat available to him. The fact that he has not applied in 2019 should tell people that J is definitely joining IIB. His preference is definitely IIB, and he is joining in the next year. J is joining here. He is joining in the third year and in his first preference. Wonderful. Similarly for N, how many people are ahead of N? 1, 2, 3, 4, 5. L and A I am not counting because L and A everyone knew they were joining IIS. So ahead of N, the people whose preferences were unknown was 1, 2, 3, 4, 5. D, I, M, G, J. Even if all 5 of them had chosen IIK, N would still have been guaranteed a seat in IIK if that was his preference. But the fact that he has not applied at all means that his preference is IIB. Which means at the end of the second year, everyone knows in the third year The two people who are going to IIB, are J and N. And as soon as J and N join, can you see all the seats in IIB are filled? Which means IIB is no longer available. IIB is not available. IIB is not available. IIB is not available. Which leads us to look at K. Look at K. In the third year, he knows that J and N want to go to IIB. So those two seats are gone. IIB is not available to him. Can he get into IIK? Most definitely. Only 3 seats in IIK have been filled up. And he is the highest ranking person left who wants to go to IIK. So K will join in this year. About C, in third round, he will join and he will get his second preference. Look at C. Sadly, his life is a waste, or his attempt of this exam had been a waste. He wanted to go to 2 places, IIB and IIS. Both those places have rejected him. You can't join IIB or you can't join IIS because all the seats are filled up ahead of C. So C is not joining anywhere. The last person left is H. He is joining in round 3, but he is joining his first preference, IIK. H joins here. And then everyone else, or everyone who had to go to some college, is done. Sadly, C does not join anywhere. C does not join. We have the precise people who are joining in every year. Let's get to individual questions. In which year did the maximum number of students join any university? This year, 4 people joined. This year, 6 people joined. This year, 4 people joined. So in 2019, maximum number of people joined any university. Who among the following did not join any university in the year 2020? C, he did not join in any year. How many students joined the university? That was their second preference. I, G, and K, they have joined universities. That was their second preference. So 3. What is the total number of seats that were vacant at the beginning of 2022 across all universities? IIK has not been able to fill up all its seats. So 1 seat was vacant in IIK. In which year did H join any university? H joined some university in 2020. So option A, and that is the entirety of the set. This is dependent on us being, see, किसको first preference मिला, second preference मिला, शुरुआत में आसान है. The key of this set lies in being able to understand the fact that L and A did not apply or J and N did not apply in the first and second year respectively gives away what their first preference is. And based off on that, other people are making their decisions and choices of which university to apply to. That will be all for this set. 4 persons, A through D, own all the shares of 5 different companies, C1 through C5. The number of shares in million of 5 companies are 20, 50, 80, 100, and 120, not necessarily in the same order. So for count of shares, the numbers available are 20, 50, 80, 100, and 120. Okay. In each of these 5 companies, the percentage shares of 4 persons are distinct positive multiples of 5. The percentage shares of 4 persons are distinct positive multiples of 5. This is a very critical condition which enables us to solve this set. In the absence of this point, everything else is useless. We'll interpret this when we come to the point where it is applicable. Okay. First thing told to us is the number of shares of C1 that A owns is same as that of C4 that A owns. Okay. Oh, even prior to that, within this cell, look at this. Within my cell, the recording that I'm going to do, on the top right-hand corner, I'm going to write the number of shares. And in the bottom left corner, I'm going to write percentage of that share. So if C1 is 20, and A has 5 million shares out of these 20. So I would want to write 5 this way. 5 here and 25 here. 5 million out of 20 and 25%. This is how I'm going to record it in the entire table so that I am simultaneously capturing the percentage share and also the amount to share. Okay, so now when we are going with these data points, the number of shares of C1 that A owns, number of shares of C1 that A owns is same as that of C4 that A owns. So if this is X, this is also X. C owns 25% of the shares of C4. Okay. So if total here is 4Y, C holds, this is not visible properly, so I will change the color. So this is Y, and also 25% I can write straight away. C owns 25% of shares C4, and the number of shares of C4 that C owns is same as the number of shares of C3 that A owns. This is also Y. Okay. B owns exactly 5 million shares in each of C2, C3, and C4. 5, 5, and 5. Now, wonderful thing. 5 by 20. 5 by 20 is 25%. Possible. 5 by 50 is 10%. Possible. Or when I say possible, what I mean is percentage share of those persons are positive multiples of 5. 5 by 20 is 25%. So this is acceptable. 5 by 50 is 10%. So acceptable. 5 by 80 is 6.25%. This is not possible. Which is to say, in this region, 80 cannot come. 5 by 100 is 5%. So definitely possible. 5 by 120 is 1 by 24, which is not 5%, less than 5%. So in this range, 120 can also not come. In this range, 120 can also not come, which means either this is 80 or 120, and either this is 120 or 80. And in this region, the three numbers that are available are going to be what all? 20 or 50 or 100. Okay. 20 or 50 or 100. B owns exactly 5 million shares in each of C2, C3, and C4, and the percentage share of B in C3 is the same as that of D in C4. Percentage share of B in C3 is same as that of D in C4. So if this is Z, this is also Z. Okay. And the percentage share of B in C4 is same as that of D in C5. If this is A, this is A. ठीक है? अब देखना, we have completely interpret line 3. यहाँ पे देखना C4 में can C4 be 20? Can C4 be 20? If C4 is 20, if C4 is 20, if this is 20, then C would also have 5 available, 25%. Then A would also turn to 25%, and we were told the percentage shares of 4 persons are distinct positive multiples of 5. So here it cannot be 20. It cannot be 20. This is ruled out. Can it be 50? If it is 50, this will turn to 12.5. No problem at all. This will turn to 12.5, which would mean this would also turn to 12.5. If this turns to 12.5, 12.5 by 20 is 62.5%, which is not valid. 12.5 by 100 is 12.5%, which is not valid. We want our percentage shares to be distinct positive multiples of 50, which means 20 cannot come here, 50 cannot come here. The only thing that can come here is 100. The only thing that can come here is 100. And if 100 is the only thing that can come, if 4y is 100, y has to be 25. If y is 25, I can place this also. Additionally, if y is 25, if this is 25, C3 100 is gone from the list.
C3 cannot be 20 anymore. This has to be 50. This has to be 20, which will also enable me to get to, this is 50%. So this here is 10%. This was Z. So this is also 10%. And this is 10. So this A is 5%. And now this X, we can get to the precise value. 25 plus 5 is 30. 30 plus 10 is 40. So this X will be 60. So this here will also be 60. This here will also be 60. This is 60%. This is 25%. Now this 60%, if I had 80 here, if the total had been 80, can you see 5% of 80 is equal to 4? 5% of 80 is equal to 4. Also, this A was identical to this 5. So this is also 5%. I'll worry about it later. 5% of 80 is equal to 4, which is another way of saying the numbers that I get here will necessarily be multiples of 4, and not just multiples of 4, distinct multiples of 4. The min possible case is for these three numbers to be multiples of 4. The min possible case is 4 plus 8 plus 12, which adds up to 24. But after placing a 60 here, I only have 20 left to distribute. These three numbers have to be multiples of 4, distinct multiples of 4. But after placing 60 here, I have only 20 left, which is another way of saying my initial assumption of placing 80 as the total here is unacceptable. This is not possible. If 80 cannot go there, only 120 can go here. If 120 can go here, this is 50%. This is done. And if 120 can go here, 80 has to go here. If 80 has to go here, we get 4 here. Wonderful. Now, also see, utilizing, now I have precise allocations available. Now what I'm also saying is, can you see in this row, whatever number comes, it has to be a multiple of 6. Whether it is A C1 or B C1 or C C1 or D C1, it has to be a multiple of 6. Whatever number comes in C5, it has to be a multiple of 4, because 5% of 80 is 4. Okay. Here it has to be a multiple of 5. Here it has to be a multiple of 2.5p. And here it has to simply be an integer. So let's say R. Here it has to be simply R. With these knowledges in mind, with these it has to be a multiple of this, multiple of that. With these knowledges in mind, we read forward. Pay attention, we have only read through first 3 statements right now. Next is the number of shares of C5 that C owns is number of shares of C5 that C owns is same as the number of shares of C1 that B owns. See, the number here has to be a multiple of 4, and the number here has to be a multiple of 6. So can I, instead of putting down something or something, can I say they have to be multiples of 12? If you are a multiple of 4 and you're also a multiple of 6, you're a multiple of 12. So I'll put it as 12W and 12W. This is a multiple of 6. This is a multiple of 4. So life is chill. The number of shares of C5 that C owns is same as the number of shares that C1 that B owns. The number of shares that C2 that C owns, number of shares of C2 that C owns is same as the number of shares of C1 that D owns. Okay. Now see, these two cells I'm talking of. So I'll put this down as 6 E and 6E. Okay, 6E and 6E. Next, B owns a greater number of shares in C1 as compared to C5. greater number of shares in C1 than C5. Okay, I'll worry about it later. While A owns an equal number of shares in C2 and C5. Okay, see here it will be some multiple of 4. Let's say 4s, and this will also be 4s. This will also be 4s. Now, how we are supposed to fill it up or work our magic here is, see, I've already got a 5 here. There is 15 available. This 4 can either be a 4 or an 8, or see, 5% is already allocated to D in C5. So the minimum possible value of number of shares that is available with A for C5 is going to be 8. I cannot go higher than 8, because if I go higher than 8, see, if this is 8, this is 8, 8 plus 5, 13 is already used up. So this has to be 6, this has to be 1. So this is 5%, this is 30%, this is 40%. If I go higher than 8, this number in A C2 number will exceed 20, or the summation will become so large that we can't really make this column work at all. So this is gone. Okay, so I have 8 here, I have 4 here. I have 8 here, I have 4 here. Okay, so the number available here, see, 8 here, 4 here. Can I say the number available here is 68 minus 12W? 68 minus 12W, or 12W. Remember, this we have done. This first part of statement 4. B owns a greater number of shares in C1 as compared to C5. B owns a greater number of shares in C1 as compared to C5. So 12W is greater than 68 minus 12W, or 24W has to be greater than 68, or W has to be greater than 68 by 24, or 2 point something something. So W can be equal to 3. W can be equal to 3. Can W be equal to 4? W can be equal to 3 or 4 or 5, whatever path you want to go down. It can be equal to 3, 4, 5, whatever. So I'm saying, see, if W, okay, I already have 6 here, no? So this is also 6. So this is 5%. This is also uniquely identified. And okay, yeah. See this. If W is 5, look at column C1. This W has to be greater than 2 point something something. It can go to whatever value it wants to. If W is equal to 5, 60 plus 60, I've already reached 120. So that would be a problem. So 5 cannot be W. W cannot be 5. This is known. How about W being 4? If W is 4, what would happen? This would turn to 48. Now see, 60, 48 is 108, plus 6 is 114. We're left with 6 again, which is not possible. These two were supposed to be distinct multiples of 5. So W being 4 is also an unacceptable case, which means the only acceptable case is W being 3, which means this is 36, this is 32, this is 36, this is 18. This now gives me 15%. This gives me 30%. This gives me 45%. This gives me 40%. And this gives me 10%. We are pretty much filled up on everything except for two numbers of C and D. Let us make cases there as well. I know the numbers have to be multiples of 2.5. So I can have 2.5 and 17.5. Percentages I'm not worrying about. I cannot have 5 here because it is already recorded. I can have 7.5 and 12.5. I cannot have 10 and 10. I can have 12.5 and 7.5. I cannot have 15 and 5. I cannot have 17.5 and 2.5. These are the 4 possible cases that can go into C3 for C and for D. These are the 4 possible cases that can go there, which also leads us to the totals we can get to 68. Sorry, 60 plus 25 is 85. 60 plus 60 is 120. 120 plus 25 is 145. 145 plus 16 is 161. For this, we have 36 plus 15, 51. 51 plus 32 is 83. Okay. Now for C, what we have is 18 plus 6, 24. 24 plus 36 is 60. 60 plus 25 is 85. 85 plus 2.5 is 87.5. 2, 15 aage, 102.5. And here I will have 6 plus 1, 7. 7 plus 4, 11. 11 plus 10, 21. 21 plus 2.5. 21 plus 2.5 is 23.5. Okay. 23.5 से 15 ज़्यादा 38.5. I have all the numbers filled up in my table. Let me get to individual questions. How many shares in million of C1 does B own? C1 ka 36 million shares. What is the difference in million between the number of shares of C2 that A owns, 8, and the number of shares of C1 that C owns, 18? The difference between them is 10. Who owns the maximum number of shares of C5? Maximum number of shares of C5 are owned by C. Which of the following is definitely true of the number of shares of C3 that D owns? The formatting is all over the place for this set. Anyway, which of the following is true about the number of shares that C3, number of shares of C3 that D owns? Number of shares of C3 that D owns is 2.5, 7.5, 12.5, 17.5. It is less than the number of shares of C5 that A owns. 8 से definitely छोटा है, not necessary. It is greater than the number of shares of C5 that D owns. 4 से definitely बड़ा है, not necessarily. It is less than the number of shares of C1 that C owns. 18 से छोटा है, yes. It is greater than the number of shares of C2 that B owns. 5 से छोटा है, not necessarily. So C has to be the answer. Last question, what is the difference in million between the total number of shares across 5 companies that A owns and the total number of shares across 5 companies that B owns? The difference here, 17 plus 61, so 78. And that is the entirety of this set. It was extremely critical that you incorporate this fact in your solving. Otherwise, processing here or proceeding here is going to be cumbersome.